Good morning, everyone, and thank you so much for coming to our spring or almost spring teleconference this morning and today. It's so wonderful to see everyone hopping into the room. I'm going to get started with the introduction because Senator Das does have a tight schedule this morning, so I want to make sure she has plenty of time to present. We're super excited to have some really impressive guest speakers this morning for the teleconference, including Senator Das from Washington, Congresswoman Suzanne Bonamici from Oregon, and then Doctors Julie Masura and Elise Granek from the University of Washington Tacoma and Portland State, respectively. And we're going to be hearing about lots of wonderful research from their groups. This is the brief schedule. We'll post the more detailed schedule, which includes breaks and more specific timing in the chat in just a moment. But again, we'll beginning with Senator Das, followed by Congressman Bonamici, and then we'll hear some research updates from both Oregon and Washington, some updates from the consortium following up on the introductory and foundational work that we did way back in Bremerton 2 years ago. We'll have an opportunity for networking and discussions about future directions, and then a report back. And the meeting will run from 8 a.m. until noon today, Pacific Standard Time. So just a quick reminder before we get started of some of our interest groups. If you're interested in getting more involved and having further discussions with other researchers or people in the consortium who are doing similar work to you, just a reminder that we have an effects interest group that meets monthly on the third Wednesday of every month. And we also have a group that is branched off from this group working on a tire synthesis and review paper. And this is led by Paul Mayer of the EPA. We have the microbial impacts interest group, which is led by graduate students Sebastian Singleton and Jared Stein, and they will be meeting this spring. So lots of exciting developments there. And then, of course, our science communication group, which as we slowly exit the pandemic, fingers crossed, we're starting to not only have the online outreach component, but we're also getting more involved in community events such as the one posted here, like Swimming Upstream, which was in Lincoln City last week, and another event that Dr. Harper will be speaking at, a similar topic this coming weekend. But let's go ahead and without further ado, get on to today's presentations. We are super excited to have Senator Monadas from Washington. She's going to talk about some recent plastic pollution legislation that she was involved in passing, and we're just really pleased to have, honored and pleased to have her here today. So I'll go ahead and let her take the stage.
Thank you so much for a great intro, Suzanne. Good morning, everyone. So lovely to be here with all of you today and to be in this fight with you to, eradicate plastic from our waste system and our waste stream. I am, truly honored to be here and to partner with all of you to protect our planet, our communities, and the harms of plastics pollution. As mentioned, I am Senator Monadas from Washington State. I represent Washington's 47th district, which includes Kent, Covington, Auburn. So for those of you who know Washington, it's South King County, so a little bit south of Seattle, about 20 minutes south of Seattle. I joined the legislature in 2019 and really ran on a platform of the environment. My master's degree is in business, sustainable business. And so really it was a big passion that I brought to the legislature and ran on that as an issue that I cared about and wanted to work on. So is something that I have been working on for the last 4 years that I've been in the legislature, and very, happy to partner with so many great organizations to get this work done. Okay, next slide. Thank you. Okay, so when I think it was about 2003, I moved to Ireland. And I've been really sort of when I started thinking specifically about the issue of plastic pollution And my experience in Ireland was the first day, you know, we got there, we went to the grocery store, and you know, this was 2003, so this is way before, you know, people in America were even thinking about this, but they asked me to pay 5 cents for a plastic bag. And I will tell you, that was the first and the last time I paid for a plastic bag. I'm cheap about the weirdest things. I'll pay $100 for a dinner and not even think twice about it. But when when someone asked me to pay that 5 cents for a plastic bag, I will tell you what, I never wanted to do that again. And you can always tell in Europe when people are going to the grocery store, because they always have like an armful of bags under their arm. And so I became one of those people. I started putting plastic bags or reusable bags in every pocket to make sure that I never had to pay for a bag again. I also at that point started thinking about, you know, what we could do differently in America, and could we implement similar thoughtful policy with sweeping impacts on our health and our planet. So that was the seed for me when I moved to Ireland in 2003. Okay, next slide, please. Now, this is a picture of me and my dad. My dad has been in the aluminum industry for now 50 years and had really, for me, was the start of conversations about recycling, because the first time I went to my dad's office when I was in high school, he picked up an aluminum can and he said, "This can will be a new can in 60 days. And it's one of those things that I don't know why it stuck with me for this many years. But for me, it really started my thought process on a circular economy way back when in high school. And I just turned 50 this past year. So it's been a long time I've been thinking about a circular economy and what that takes to build one. And for me, it also started my commitment to protecting the well-being and protecting the well-being of our planet, you know, long started before my trip to Ireland. It started really with this incident that I had in high school with my dad. So also fast forward during that time, or back forward, I guess, he also mentioned to me that one of his biggest customers was L'Oreal in Paris. And I remember I asked him, I said, well, why is that? And he said, how do you think the makeup gets so shiny? And so that was the impetus for the bill that I introduced this year to remove harmful chemicals out of makeup. Okay, so next slide. Okay, so in 2020 was my second year in the legislature, and it was my second year trying to ban plastic bags. We had so much corporate pushback, and believe it or not, most of it came from the pulp and paper industry, which really made no sense for us because, you know, once we banned plastic bags, obviously we were going to be moving towards paper bags. So we worked for 2 years to pass this bill, and we had great bipartisan support. We ended up with an amazing statewide coalition, which included not only the environmental community, but also the labor community. And it also included the grocers, both the large grocers and the small grocers. Because what had happened was we had passed this plastic bag bill in, I think it was 27 different jurisdictions around Washington state. And so the grocers actually wanted continuity because, you know, in some areas it was 5 cents, some areas it was 10, and some areas it was, you know, other different monetary amounts. And so they really asked us to pass the bill so that it would be statewide and it would be the same for everyone. And so that was such a unique coalition of stakeholders. And we actually also had the chemical industry was also bought in as well. And so we were so proud to work on the bill. Again, like I said, it took us 2 years to pass it, but we did end up passing the bill. I'm proud to say that it was implemented last year. And it's one of those bills that, you know, you see when you go to the grocery store, there's a big sign that says all plastic bags will be 8 cents. And so for me, it was like seeing my legislation put in action, which was was really powerful. So it was really, we were very proud to pass that bill in the Reusable Bag Act in 2020. Working on this and other bills, my colleagues have dubbed me the single-use plastics warrior of Washington State, which I absolutely wear that badge proudly and am very honored to have that distinction. Okay, next slide, please. Okay, so let me tell you a little bit about some of the stuff that we're working on now and some of the context for that. Okay, next slide, thanks. I want to tell you the backstory because it's important to know that the work we're continuing to do in Washington State has a foundation, and it's driven by an urgent need to do something. And to gain that amount of support from the public, that our work is taken into action. So this graph really brings it home for me, as I'm sure it will for you. Studies have indicated that our plastic waste problem is just going to get worse. And in the next 30 years, we are projected to generate 4 times the amount of plastic waste than we ever had. And I'm sure I don't need to tell this group about that. But around the world, the rise in the projection of plastic waste, it's projected that we increase plastic waste by 4 times, and that's something that we need to tackle. So it's not just work that we do individually. Obviously, I'm sure all of you, like I do, go above and beyond to make sure all of your waste is recycled. But we need to have legislation. We need to partner with our state governments to make sure that we continue, to make sure that we continue to tackle this problem. Okay, next slide. As you all know, like I do, when you go to your recycling bin, we all do what well, hopefully we don't do it anymore, but many people wish recycle, right? They throw things in the bin that they hope and wish could be recycled. So there's many products that are designed, and I do believe this is a design problem. We need to tackle it from the beginning. We need to tackle it from the parts where the items are being designed. If we keep designing products that aren't meant to be recycled, we're going to keep having this problem. And I like to say in 2022, we should no longer be creating products that aren't reusable, recyclable, or compostable. We have the technology, we have the creativity. There are many companies out there that are doing it, and we need to follow in their footsteps. There's really no excuse for plastic waste anymore. And we should have stopped making excuses a long time ago. So that's partly what I'm working on and what we've been working on together. Okay, next slide. This slide really highlights the rising costs and the shrinking services that we are providing our community members. And this is another problem, especially for folks in my community. Folks are shouldering more of the cost of recycling. At the same time, they're seeing a range of their recycling services decrease in their communities, especially in rural and unincorporated areas. Recycling services are becoming even more limited and more expensive if they had them at all. And so, next slide, please. So, thank you. Last year, we tried to tackle this problem on a wide variety of fronts. We had 4 parts of this legislation, and it was the first in the nation policy to improve the streamline of our recycling system, and it really was in 4 parts. The first, which I'm the most proud of, is that we banned a lot of styrofoam. So we banned those coolers that obviously, get taken to the beach and then left there, that break down and become part of our waterways. And we know that our fish are ingesting a lot of this waste. We banned those packing peanuts, which I know everybody hates. And I'm happy to say I haven't received a package with packaged peanuts in a long time. So that's been great. We also banned cups and plates and those clamshells. And obviously I know with COVID, a lot of folks are getting more and more takeout, as I have been. So it's that will be implemented, I believe this year, to remove the styrofoam clamshells. The second piece of the legislation was the post-consumer recycled content. So, you know, in many products, we'll need to do 50% of recycled materials in plastic bottles. That included water bottles, soda bottles, milk jugs, which I'll tell you was a fight with the dairy industry, of course, cleaning products, shampoos, conditioners, and even, I believe it was first in the nation for garbage bags. So we're really proud of that. The third piece of this legislation was to make things available upon request only. That includes condiment packets, straws, even the cup lids. I know that was the first in the nation. And condiment packets, I think I said that already. So that was, and utensils. And of course, you know, the most annoying thing is when you ask, you know, maybe you just need a fork, and then you get that variety where you get the spoon, the knife, and the fork and the napkin all together. So that's that makes that part of the bill makes all of that available upon request. And the fourth part of the bill was the confusing part of the chasing arrow symbol, because it was required to always have a chasing arrow symbol, and so that really contributed towards that waste recycling. So we removed the requirement to have the chasing arrow symbol. Okay, great. I think I did see someone raise their hand. Does someone have a question? I'm not monitoring the chat.
Sure. If someone has a question, please either put it in the chat, which I will monitor, or raise your hand and we will unmute you, or you can unmute yourself.
Okay. All right. Next slide, please. Okay, so this year we introduced the Renew Act. We wanted to keep that momentum up for this session and really talk about a circular economy. And we were very, you know, excited that Oregon had passed the Extended Producer Responsibility System bill, and Maine. So we had been monitoring those bills and really tried to get to a point where we could take what we thought was the best of the Oregon bill, the best of the Maine bill, and move it forward. And I'm really proud of how far we got. We got so many stakeholders to the table. We had over 100 stakeholders in our meetings, and we got really far. Newsflash, it didn't pass this year, but that just makes us more excited and having more momentum to keep the pressure up for next year so we can get it across the finish line. We are really proud of the work that we did. Next slide, please. Some of the components of the bill included targets, extended producer responsibility program specifics, as we talked about. It had some post-consumer recycling content for additional product packaging and post-consumer recycled content for the bins, because we know that is really important. And we wanted to really bring in components for accurate labeling. Okay, next slide, please. When we passed this bill, I think there were 9 states, both last year, we did start off with our EPR bill last year as well. I think there were 9 states total that were going to do EPR legislation this year. And it was great over the summer, over the interim. I got to meet with many of those legislators in Washington, D.C. NCEL is an organization that brought us all together so that we could, you know, work together and make sure that we could support each other as we try to pass this legislation. We know that it's the leading edge of environmental policy, and we really tried to create a bill that would be model for other states. And, you know, we really need to address our plastic pollution crisis. And for us, we, instead of continuing to keep negotiating and degrade the bill, we decided to keep the bill as is so that we had a great launching off point for over the interim when we start to negotiate the bill again. Okay, next slide, please. Thank you. one of the things that motivates me, especially as a woman of color and one of very few in the legislature, is really the work on environmental justice and how these bills really are environmental justice bills. So, again, really proud to pass the Reusable Bag Act in 2022, and really, excited to continue working on the Renew Act, because we know that these communities that have lower income folks and communities of color really do bear the burden of environmental harm. So we really need our whole state, our nation, our globe. I mean, we cannot continue to thrive and keep pushing the problem of waste onto other people. And so really, for me, this solution begins at the source, the people who are creating the packaging and the people who are buying the packaging, because we as consumers get stuck with the packaging choices that somebody else has made, and that is no longer acceptable. Okay, next slide. As I mentioned, there's a lot of states that are addressing waste, and they are creating this great momentum. I'm so proud to be part of these states that are leading the charge on recycling and producer responsibility. We really can't address our deeply rooted problems without facing hope. So I do have a lot of hope, especially when I see graphs like this. I feel the hope, and I thank you to all of you. I mean, especially our advocates and our community members that are pushing for policies in their states and in the states that you are all in. I know there are a lot of West Coast states here represented today. So I want to just say thank you for all we've accomplished so far, and know that together our strength of this movement is growing, and that together we can, really make great impact. Okay, next slide, please. These are my nephews, and I don't have kids, but I have these fabulous nephews that got to visit me a few years ago in Olympia. And these kids, my nephews, are really my why. It's why I do this work. It's why I work so hard. It's why I partner with all of you and look at your organizations for help and strength. I do believe that every child in my community in Washington and in your community and around the world, we know they're going to be inheriting both our problems and hopefully our solutions. So we want to set them up well and make sure that they are not continuing to deal with the plastic pollution that we've created. Next slide, please. So I want to say thank you for joining me in this work. It's an honor and a privilege to work with all of you to get these bills over the finish line. And with that, I'll conclude my formal remarks. And if you have any questions, I'm happy to take them.
Senator, thank you so much. It's so wonderful to hear about all the progress that's being made in Washington. I have a few questions in the chat, and then if anyone else has questions, feel free to pop them into the chat or raise your hand and we can unmute you. But a couple of people had questions about specifically the removal of the chasing arrow symbols and how people will know whether it's recyclable or not. One person comments that their dad is an avid recycler and he looks for that symbol.
Yeah. Well, what we did was we removed the requirement that they had to put the chasing arrows on. So what was happening was things that weren't recyclable were, since it was required to have the chasing arrow symbol on it, they would put it on there, and that product wasn't, that packaging was not recyclable. So people would then see the chasing arrow symbol and then throw it in the bin thinking that it was recyclable. So this just removed the requirement to have it. So if you are packaging that is recyclable, then you could still use the chasing arrow symbol and then that product would get recycled.
Okay.
So that was it. We just removed the requirement. Yeah, great question. Sorry, thanks for that clarifying.
No worries, that makes sense. And then another question about the map you had shown of the US. someone says, I'm assuming darker means that there's more movement forward. For the states that were highlighted, they were just asking if that means, and how is that movement forward measured?
I'd have to look at it again, but I think that it was showing which states were doing more work in that. And I did notice Oregon was not blue in any way, so I was wondering about that too. I know Heather provided me with that slide. I know she's here. She might be able to answer that question.
Yeah, that was an NCL map from 2020. They don't have an updated map, unfortunately, and it shows the bag bills. And so Oregon didn't have a bag bill at that point.
Oh, okay, that's what it was. It was for bag bills. Okay, yeah.
Okay, yeah, we have local bills, but not a statewide bill, or at least we didn't at that point. I was wondering though, I know that Oregon passed an extended producer responsibility bill this past August. Are there a lot of similarities between the bill that was passed in Washington and the bill that was passed in Oregon?
Well, we didn't pass our EPR bill this year. We tried very hard, but we did take a lot of the parts from the Oregon bill and try to get those in. I mean, especially we're really working on the targets and needs assessment part of the bill. And I mean, as these bills start to gain momentum, I know Maryland used a lot of what we had done, the work that we had done here in New York, used a lot of our language. So, I mean, we're just trying to figure out which combination is going to work and which combination is going to bring more folks to the table and more folks to consensus.
Wonderful. It looks like Win Calger has his hand up. Go ahead, Win.
Thank you. That was a really great presentation. Really appreciate you joining us. One thing that I think about a lot is that recyclability of different objects is really heterogeneous throughout localities, cities, counties. Every single city has their own kind of abilities to recycle things. And I'm wondering, I'd like to see in the future some sort of like basic infrastructure for everyone, for every single household in the United States, of like you have the infrastructure at your disposal to recycle like all of the goods that we produce in the United States, and that eventually the end goal is that we just like put everything into one bin. It's the recycle bin. So yeah, I'm wondering like what do you think is the path to that future, to creating the infrastructure needed and the systems needed to have like that kind of massive scale recycling? Yeah, thanks.
Yeah, that's a great question. I think it's twofold, right? I think what happens is local cities adopt something based on what their jurisdictions can do. Then we move up and we pass something that's statewide, and then that pushes it out for the whole state. And then once multiple states pass something, then there's precedence for it to pass on a federal level, a national level. And so that's really sort of what I found, especially with the plastic bag bill. When we passed it, like I said, there were 27 jurisdictions that had already passed it. And then the proponents were begging for a statewide solution. And eventually it will move up that so many states have passed a bill like this that there will be a need for a national legislation. So that's kind of what I've seen in my short time in the legislature, is the reason why it's important for jurisdictions to pass something, then for the states to pass it. And then there's more precedence for it to pass nationally. Great question.
And it looks like if you have time for one or two more questions.
Yep. I've got time for probably one or two more, yeah.
Sounds good. Brooke Ashcraft, go ahead.
Hi, thank you. And thank you for joining us, Senator. It's really nice to have you on. I'm wondering, so I'm from Washington, and in the last couple of years, I know that China has stopped taking our recycling. I'm wondering what, and you may have mentioned it before, what movement there is to create infrastructure to recycle here in Washington.
Yeah, that's a great question. So I think it was my first year in the legislature, we passed a recycling development center bill for the Department of Ecology to start researching what we can do here in Oregon. In Washington. I lived in Oregon for 17 years, so sometimes I still
No
say
worries.
Oregon, especially when I know there's lots of Oregonians on the call. So one of the things that we explored in this bill, the EPR bill that we had this year, was what would it take for us to recycle glass and to get glass repurposed, because glass is so heavy, right? So transporting it is often the most expensive part of glass. And so there's definitely conversations happening about doing local recycling and reuse and regeneration, or to build circular economies within our state, for sure.
Cool. Thank you. I appreciate it.
Thanks for the question, Brooke. All right, I think I can do one more.
Wonderful. I think we have a really good finishing question in the chat here. And the question is, are there policymakers that you've worked with that are against plastic waste reduction? And if so, what do we need to do? What kinds of research do we need to conduct that would convince them otherwise?
Yeah, that's a great question. I will say on our plastic bag bill, it was actually bipartisan, because the grocery stores asked them to pass the bill. And so that's really what I've seen works really effectively, is when advocates that they listen to or care about are actually asking for the bill as well. And when in this year with our EPR bill, in order to get to neutral, we needed to bring the waste management industry in. And so that's what we're going to work on over the interim. And I do believe once we get there, that the waste industry, especially out in rural Washington, I mean, right now they have no recycling in many of those communities. So, it was perplexing to us because, having a mandate on recycling would mean that more business for them, right? They would be getting more money. So once we can thread that needle and make sure that our rural folks are feeling bought into the process, I do believe we will get bipartisan support on this bill next year. And I'm really excited about what that looks like to keep going. So
it's wonderful to hear. And thank you so much for making time to chat with us today. We greatly appreciate it. And we're so excited to hear about all the progress happening in Washington.
Yeah, thank you so much for having me, everyone. Have a great morning.
All right. Thank you. Have a wonderful day. All right. Right. Without further ado, I'd like to welcome Congresswoman Suzanne Bonamici, who has joined us from Oregon, from Salem, I believe.
Actually, I'm in Washington, D.C.
Oh, okay. Washington, D.C. Wonderful. Well, it's so wonderful to have you. And again,
Thank you.
Thank you so much for making time for the group today. We're so excited to hear from you. Did you have slides that you wanted to share? Or
I do not have slides, but I'm really thrilled to be here. It was nice to listen to the senator from my neighbor to the north up in Washington. But thank you so much for the invitation to join you today at the Pacific Northwest Consortium on Plastics at your annual meeting. And I'm sorry that I can't be with you in person. I'm actually here on the East Coast, but I appreciate your efforts to address plastic pollution, your efforts in the region to address plastic pollution, which is something I care about deeply. I'm proud to represent Northwest Oregon in the U.S. House. The district I represent, the Columbia River serves as the northern boundary. The Pacific Ocean is the western boundary. And Oregon's economic vitality is really dependent on the health of the ocean and the lower Columbia River estuary. Healthy beaches and waterways are critical to the marine ecosystems that thousands of people rely on to earn a living in Oregon and other coastal communities. And and I've looked at this statistic many times, that every minute the equivalent of a garbage truck full of plastic is dumped into our ocean. According to the United Nations, that's more than 8 million tons a year. And unfortunately, the issue has only become worse during the COVID-19 pandemic, as families have increasingly relied on online shopping and delivery services for necessities like food and supplies. The demand for single-use plastics has actually grown significantly, which, as we know, is the wrong direction, because we know that marine debris harms our coastal economies, endangers wildlife, destroys important marine habitat, propagates invasive species, and also creates hazardous conditions for the maritime industry. Microplastics, I want to say, are of a particular concern. They harm marine life by blocking digestive tracts. They alter growth and in some cases kill animals and marine organisms. And microplastics bioaccumulate. They affect species up and down the food chain. Last year, Environment America surveyed 30 lakes, rivers, and urban waterways in Oregon, and they found that each contained at least one type of harmful microplastics. So they are everywhere. And we don't know how long it takes for plastic to completely biodegrade, but the estimates are from 450 years to never. So preventing plastic debris from infiltrating our waterways and wildlife and food is also entirely possible. The recent activity in the Oregon legislature and the Congress demonstrates a will and a commitment to addressing the problem. I know I served in Salem, both in the House and the Senate before I joined Congress, but I know that last year, Governor Brown signed into law the Plastic Pollution and Recycling Modernization Act. The bill will require plastic producers in Oregon to pay a part of the cost of collection and recycling, and that makes Oregon the second state to impose this requirement. And last Congress, my bipartisan Save Our Seas 2.0 Act was signed into law. I am the co-chair of the Oceans Caucus and the Estuary Caucus, both bipartisan caucuses here of members of Congress who really care about this issue, and we've been working on Save Our Seas. This is the second iteration and update of that law. This legislation authorizes a prize competition to advance innovation in the removal and prevention of plastic waste. It directed federal agencies to support efforts of foreign countries to improve waste management, because we know that it's not just a US problem, it's a global problem. It also directs the Environmental Protection Agency to strengthen markets for recycled plastics and also improve waste management infrastructure. And the bill is going to help address the pervasive effects of microplastics on our ecosystem and also decrease the quantity of plastic debris in our rivers, our estuaries, and our ocean. But eliminating single-use plastic is critical to our fight against plastic debris, which is why I also support the Break Free from Plastic Act. This will ban certain single-use plastic products and require producers of plastic to finance recycling programs, similar to laws that Oregon has enacted. We also need to aggressively pursue plastic pollution mitigation, because we can't eliminate single-use plastics overnight. To support this effort, I've introduced an amendment that was included as part of the recently House-passed Competes Act. This amendment directs the Office of Science and Technology Policy here in the Biden administration to develop a national circular economy roadmap, including a vision for how our nation's science and technology enterprise should support a national circular economy plan. We know the plastic pollution problem is significant, and we also know that our policies must be ambitious. Immediate action is necessary to mitigate and prevent plastic pollution from further harming our ocean and ecosystem. So thank you for your leadership and your advocacies on these issues, and I look forward to our continued work together. And I believe I have time for a few questions. I'm in two hearings at the same time today, so I have set aside a bit of time for questions, and I think those are going to be in the chat. Is that correct?
Yeah, I'm monitoring the chat, and then also let people know that if they had a question, they could raise their hand. Thank you so
Great.
much. It's so wonderful to hear about all of the progress that's been made and efforts going forward. And
I appreciate that. Still work to do, but we are making progress.
Yeah, definitely. The extended producer responsibility bill is just it's inspiring, and I'm hoping that more states will go in that direction. Does anyone have any questions for Congresswoman Bonamici? I had a question. Oh, go ahead, Ariadne.
Sure. I also want to hear your question, but my quick question was, you mentioned how you are encouraging support for the nation scientists to develop technology that'll help prevent plastic packaging. I'm wondering, how are you helping channel that support?
Well, we included this as an amendment, the Circular Economy Roadmap. That's an amendment in the Competes Act, which has passed the House. The Senate has a similar version. You might have heard of it as the CHIPS Act. But we're expanding it. It's really about bolstering our economy and U.S. manufacturing, but also the Break Free from Plastics Act require producers to finance their recycling programs is important as well. But I serve on the in addition to serving on as co-chair of the Oceans Caucus, I also serve on the Committee on Science, Space, and Technology. And so really the investments that we make in research and development are really critical as well. One more thing I want to add too is that I serve on the Select Committee on the Climate Crisis. And even though plastic pollution is not necessarily a climate change issue, ocean health is. When our ocean is not healthy, our planet is not healthy. And we know that plastics are a significant part of the ocean pollution.
Thank you so much.
Looks like we have a question from Wynn. Go ahead.
Yeah, thank you. I know Suzanne brought this up in the chat. The UN just convened UN EA 5.2, and they had a global agreement on plastic pollution that seemed like it was currently they passed a resolution on it, which is really exciting.
It is exciting.
Yeah, I'm wondering how we can make sure that here in the United States that we are, amplifying the agreements and recommendations that are made at the UN. I don't really understand how like international policy works, to be honest, and how our government fits in with it. So I'm kind of wondering, like, how is this going to play out here in the United States with us kind of like implementing this resolution?
Right. Well, thank you for the question. And there was bipartisan input as the UNEA was getting ready to meet. In fact, a couple of senators joined, some House members, including myself and Representative Young from Alaska. We co-chair the Oceans Caucus. So it's a bipartisan letter that we sent to the Assistant Secretary of Oceans in International Environmental Scientific Affairs. So this administration has quality people working on ocean health issues. And we were urging the State Department to work with Congress on these negotiations. So some of it's through the State Department. There are a lot of opportunities through trade agreements and other ways to work on these international issues, and Save Our Seas as well. Save Our Seas really does encourage international collaboration. So I was excited to know that there was this bipartisan support for the UNEA agreement. So we'll be monitoring it and working with the administration on it going forward.
Thank you.
You're welcome.
Wonderful to hear. I have a question in the chat about the circular economy and focus on trying to create circularity, which is great, but is there a potential for toxic substances to be recirculated and amplified, kind of an unfortunate and potential negative side effect of that?
Sure, that certainly would not be the intent. And there
Right.
are pieces of federal legislation like the Toxic Substances Control Act and others that deal with toxic substances. So, that is not the intent to. I'd share that concern as well about circulating potentially toxic substances. So, we'll keep an eye on that as we work on the circular economy issues.
Wonderful. And my question was more along the lines of microplastics. We're making great strides in terms of improving recycling options and thinking about extended producer responsibility. But as you're probably aware, our neighbors to the south just passed a statewide microplastic strategy. Is Oregon thinking along those lines in terms of either, thinking about bills that would encourage more collaboration between scientists and policymakers to try to move forward a bit on the microplastics issue?
Well, I can't speak to what the state legislature is doing, but I know that here in Congress, For example, I mean, when you talked about our neighbor to the south, are you talking about California or Mexico?
California, yeah.
Okay. No, one of the things I did work on, because we're working on federal issues here, when the USMCA, the United States Mexico Canada Trade Agreement, was renegotiated. It was like the renegotiation of NAFTA, which was very problematic trade agreement. We worked hard to get environmental provisions in the new trade agreement to make sure that they're addressing the toxic pollution on the borders and with our trading partners. So those are some of the things that we can do at the federal level, as we look at international trade agreements, for example, make sure that those environmental provisions are in there that address things like plastic pollution and healthy oceans.
Thank you so much. And sorry, I didn't specify which neighbor to the south.
Sorry, that's all right.
Information. Does anyone else have any questions for Congresswoman Bonamici? Really have her for a few more minutes this morning before she gets on with the rest of her day. Although, of course, it's a bit later there.
It is, yes. And I'm on the Education Committee and the Science Committee. In fact, the Science Committee is starting any minute, where we're having a hearing that deals with ocean health and research.
Wonderful. Scott, go ahead.
Hi, Scott.
Hi. Hello, Scott Coffin here from the California State Water Board. And I just have a question about bioplastics. Bioplastics are being touted as a sustainable alternative to petroleum-based plastics. And in some cases, they probably are a much better alternative. But I worry that using a lot of corn and bioresources to make physical materials instead of food may exacerbate existing food insecurities and further deplete our nutrients. And I'm wondering if you have any thoughts about that.
I share the concern. I do understand that some of the bioplastics are better than petroleum-based plastics. What I can say is we'll keep an eye on that. I know the same concern is raised about ethanol, for example. We'll keep an eye on that, because food insecurity is a real issue, and whether there are particular, I don't have enough expertise in that area to know whether there are particular crops that are grown specifically for those purposes that aren't crops that would be used for addressing food and hunger needs. But I do know as well that the ocean and our lakes and rivers are a very large supply of food and protein for many people in the United States and around the globe. And if our lakes and rivers and ocean are not healthy, those food supplies are threatened. And I have that concern as well. So we'll keep an eye on the bioplastics. I see them as a step in the right direction, but we want to make sure that they aren't creating additional problems, like you mentioned, Scott.
Thank you.
Thanks. And Lyda, I see you have your hand up. Go ahead.
Yeah, thank you. Thank you for joining us today. I was wondering if you could speak a little bit about some of the things you touched upon, both how plastics perhaps are or are not directly related to the climate change issue, and also how the big oil companies are huge lobbyists for basically the anti-break free from plastic movement, but how as oil gets more expensive and how we're moving towards electric cars and more sustainable resources, they're creating these cracker facilities that just end up producing more and more plastic film. So I'm wondering, from a federal government point of view, is there anything being done about that, or how is the government, bipartisan support, anything looking to stop those cracker facilities or move towards a more sustainable system, given the increase in oil prices, given how it seems like the entire world, other than us, is moving towards these very, very sustainable plastic-free solutions?
Well, thank you for the question. And I can't say, I don't have the expertise to know what many other places are doing, but I do know that bills like the Break Free from Plastic Pollution Act, which I am co-sponsoring, are really critical. I do know as well that from the work on the Select Committee on the Climate Crisis, that we laid out a comprehensive science-based climate action plan to transition to clean energy and away from fossil fuels. That is available. Maybe Jenna from my staff would mind putting that that link in the chat if you're interested in that. And I don't know the future for the Break Free from Plastic Pollution Act, but I know I support it, and it's building support here to really move away from single-use plastics and pause. This bill will pause the permitting of new and expanded industrial facilities that create new plastic or convert it. So it's an important piece of legislation, and we keep building support for it here in Congress. But yes, with regard to the oil companies, that yes, they have a lot of influence. Do I support campaign finance reform? Absolutely. But in the meantime, we're going to keep working on these issues to make sure that what we're doing is good for the people we represent and good for the planet. So we're not going to let the oil companies and the lobbyists get in our way, and we'll just keep building support. And as I mentioned, some of these pieces, like Save Our Seas, have been bipartisan, have been signed into law, and we'll continue to do what we can to make further progress.
Super, thank you.
Of course. All right, thanks everybody. I'm going to go get on my other hearing, but I really appreciate the opportunity to be with you. I see Stacey Harper from OSU is here. Thank you, thank you. We're honored to work with Dr. Spinrad, of course, our head of our National Oceanic and Atmospheric Administration from Oregon State University. So thanks everyone. Nice to be with you. Take care. Thanks for your advocacy.
Thank you so much.
Take care. Bye-bye.
Have a wonderful day.
You too.
All right, everyone, we're going to have a short, I guess, 8-minute break until 9 o'clock, and then we'll be hearing from several researchers at Portland State University. So see you in a few minutes. All right, so next up this morning, we're going to hear from the Granek Lab, the research group, Applied Coastal Ecology group at Portland State University. They've been doing some work that's been funded by Oregon Sea Grant in collaboration with Oregon State and others. So without further waiting, I'll introduce Dr. Granek, who's joining us from Portland this morning. And you should be able to share your slides now. For some reason, it always defaults to the host sharing.
No worries. Thank you.
Thanks so much for joining us today.
Yeah, thank you, Suzanne and Stacey, for inviting our lab group to present. We are really excited to share some of the research we're doing. I run the Applied Coastal Ecology Lab at Portland State University, and a subset of the research in the lab is on microplastics in the Pacific Northwest. And so I just want to acknowledge our funders for the work I'm going to mention, which include Oregon Sea Grant and the USGS-PSU partnership. I just want to highlight some ongoing research that hopefully we'll be able to share in more detail with you all later in the year or early next year. And before I introduce the students from the lab that actually have research to present to you today. So I just wanted to mention some research going on. PhD student Paul Hurst is working on research looking at microplastics in salmon in the water around where the juvenile salmon live, in the juveniles themselves, and looking at effects on of exposure on those salmon. Oops, sorry. Here, Allison Bourne, a master's student, is looking at the effects of anthropogenic fibers and how effects differ based on whether those fibers are fully synthetic, semi-synthetic, or anthropogenically influenced. Tessa Paulson, also a master's student in the lab, is looking at lessons from California microplastics legislation and how we may take nuggets and lessons learned from the California process to inform potential legislation here in the Northwest. And undergraduate student Marilyn Duncan is looking at how or whether the extent to which microplastics and pharmaceuticals and personal care products co-occur in wastewater, and whether there may be utility in using one as a proxy for the other. So without further ado, I want to introduce the two graduate students from my lab group that are finishing up this year and have research ready to present. I actually don't know who was scheduled to go first, so maybe this is out of order. But Maya Hurst is going to talk to us about stakeholder perceptions of microplastics management. Yes, okay. And following her will be Summer Traylor, who will be talking about microplastics in Oregon, from Oregon's ocean to table. And so I will stop sharing and pass on the mic to Maya.
Great, thanks so much. Let me just share my screen here. All right, can you guys see my presentation here? Okay, great. And it's not with the notes. Okay, cool. Great. So thanks everybody for having me today. I'm excited to talk to you. My name is Maya Hurst Meyer. I'm a graduate student at Portland State University in the Master's in Environmental Science and Management program. And today I'll be talking to you about my project on stakeholder perceptions of microplastics management in Oregon. So there is currently a lack of policy in the US that focuses specifically on microplastics management, and that's what I'll be addressing today. Before I get more into this, I'd like to remind everybody of some major sources of microplastics pollution, and these include, but are not limited to, tire wear particles, microfibers from washing of clothes and textiles, as well as plastic production pellets and fishing gear. So we've all heard of some of the state bag and straw bans, and you may have also heard of the Microbreed Free Waters Act of 2015, which limits the use of microbeads in personal care products like toothpaste and face wash. And while these are relevant to microplastics, they're not specific to key sources of microplastics. Another potential policy that was mentioned earlier today is the Break Free from Plastic Pollution Act, which was reintroduced to Congress last year and has not yet been passed, but it would take some steps to getting closer to the sources of plastic pollution. So one state in particular, California, has begun acting on microplastics. Senate Bill 1422 initiates a formal definition and measurement system for microplastics in drinking water. And back in 2020, they officially adopted the definition for microplastics. And at the end of last year, they set a standardized measurement method for microplastics in drinking water. And then Senate Bill 1263 requires California to adopt a strategy to reduce the ecological impact of microplastics in marine ecosystems in the state. So where does Oregon fit into all of this? While no other state has a microplastics policy for measurement, other West Coast states like Oregon and Washington are expected to learn from and follow California's lead on this in the next few years. With that in mind, Oregon is very different from California, and using the same drinking water approach may not be realistic for this state. We don't have the same resources, and in addition, there is a tradition of collaborative resource management here in Oregon that could provide alternative approaches to this issue. And as Oregon is expected to act on microplastics in the near future, it's important to understand the attitudes of the groups who would be involved with management of microplastics and determine the opportunities and barriers to this. So this brings us to my study. The research question for this project is, how do Oregon water quality stakeholders perceive the potential for management of microplastics in Oregon? And a sub-question to this is, what are the priorities, concerns, and barriers of microplastic stakeholders in Oregon? Stakeholders are defined as individuals employed by organizations in industries that are or are likely to be directly affected by microplastics or are likely to be engaged in control. So basically, we're looking for individuals to interview that were more likely than the average Oregonian to know about microplastics based on their job. And we used chain referral methods to find more interviewees, and interviews were recorded in Zoom during COVID and transcribed by Otter AI software. And then we conducted analysis using Max QDA software. So our methods included a short 7-question survey to gauge the perceptions of each stakeholder to microplastics pollution. And this survey provided a structured instrument that kind of complemented the semi-structured interviews and allowed us to compare across participant pools. After having participants fill out the surveys, we conducted semi-structured interviews with each participant and got longer responses and explanations. And that just allowed us to go deeper into the qualitative information that the survey questions could not quite capture. There was a set of 9 consistent long answer questions asked to every interviewee. And then we had other specific questions based on each particular interviewee type. So this pie chart shows the breakdown of interviewee organizations. As you can see, the majority of interviewees were government, either state government, federal government, or local. And then the fishing and seafood industry included recreational fishers, seafood industry, and tribal fisheries management as well. And the rest of the interviewees we spoke with were academic, engineer, or waste disposal. In total, we conducted 28 interviews. And while it would have been nice to get a more balanced number on some of these types of organizations, it was harder to break into some communities than others. And that's something we're hoping to address following my project. So finally, let's get into some of the results. One interesting result from the survey findings was that stakeholders are showing personal concern for microplastics and ranking it around 3 or higher on a scale of 1 to 5, with 1 being least concerned and 5 being the most concerned. But stakeholders don't tend to rank microplastics as serious as other marine issues. So this graph shows how interviewees ranked 5 current threats to marine ecosystems on a scale of 1 to 5, with 1 being the most serious and 5 being the least serious. And as you can see, most participants marked microplastics around 3 or 4 in terms of seriousness. Other issues like ocean acidification and marine heat waves seem to be more serious by the majority of interviewees. So getting into some of the interview results, one notable finding was that available information on microplastics does not seem to be reaching stakeholders. Stakeholders, especially government respondents, perceive that there is limited information available on microplastics. And this was supported by some of their statements that there was no available information on certain aspects of microplastic pollution when that information actually does exist. Both the seafood industry and government respondents mention that education for the general public on microplastics is needed. And in general, these results show a need for information pathways to disseminate microplastics research to the community. And in general, during the interviews, I noticed many participants had trouble identifying management approaches for microplastics in general. And in addition, given that certain industries were hesitant to talk to me about the issue, these things suggest that there seems to be a knowledge gap between the microplastics research community and the greater water quality management community. And it seems that the information that we have in this particular microplastics community is not reaching outside of it. So another theme we noticed was that the state agency stakeholders do not feel that their agencies have the authority to address microplastics. I did talk to some federal folks as well and heard similar things from them, but the majority of them described their agency as not having a regulatory role in managing contaminants like microplastics is just not in the scope of their agency. These results suggest that state legislative policy would be needed to have an effective effort to manage microplastics, since none of the tools available to state agencies can be used unless the legislature acts. And then one last notable finding was that most groups of stakeholders mentioned human health as an important aspect of motivating management action. While many also noted it is important to address ecosystem effects, they highlighted management action that would be more motivating to talk about human health concerns around microplastics, and this implies that appealing to people's concerns for their personal health would be an effective way to encourage management efforts. And research on exact human health effects of microplastics is still emerging, but this provides a basis from which to regulate the contaminant. And finally, I just wanted to say thanks to my project team, as well as the participants who took part, and Oregon Sea Grant for funding this project. Thank you.
You did. There we go. Thank you so much, Maya, for a great presentation. I think we'll hold questions until the end. And Summer, you're up next. Let me know if you can't share your screen.
Cool. Can everyone see my slides? Okay, awesome. Thank you. So hello, everyone. My name is Summer Traylor. I'm a master's student from Portland State University, and today I'll be sharing my thesis work titled Microplastics from Ocean to Organs Table. So as we're all painfully aware after this morning's presentations and talks, the problem of microplastic pollution has grown to a scale where microplastics are now found in every type of environment, both aquatic and terrestrial. In recent years, we've put a focus on aquatic organisms, more specifically seafood species, and tried to quantify the amount of microplastics being taken in by these organisms. So studies have focused on mostly the digestive tract, but we're now realizing that microplastics are somehow translocating from, other places in the body to the muscle tissue that we actually eat from these seafood species. So with very little studies conducted so far on muscle tissue in general, we initiated a study to focus on the muscle tissue of Oregon seafood species, both purchased from retail markets and from freshly caught off of vessels here in Oregon, mostly to quantify microplastic pollution. So for this study, we looked at 5 finfish and 1 shellfish, including Pacific lamprey, Chinook salmon, Pacific herring, black rockfish, lingcod, and pink shrimp. We focused on answering 3 main research questions. The first being, is there a difference in microplastic burden between retail purchased and vessel caught Oregon seafood species? The second, when looking at different life stages of Pacific lamprey, is there a difference in microplastic burden between these 2 life stages? And lastly, is there a connection between microplastic burden and trophic level across all of these species? So for the methods that we followed common protocol in the microplastic field. We first took biological measurements of all the species after rinsing them with DI water. Tissue samples were then taken from each individual, and each sample underwent a 24-hour potassium hydroxide digestion at 40 degrees Celsius. And here you can see some of that process. Samples were then filtered through a 10-micron polycarbonate filter. Filters were visually inspected using a compound microscope, and microplastic characteristics were then recorded. And here's a lovely photo of our pink lab attire for contamination control. So over the next few slides, I'll show you the results of our microplastic counts and attempt to answer our first research question. So this first slide shows a comparison between our vessel caught pink shrimp in blue and our retail purchased pink shrimp in green. So we see that across a sample size of 30 individuals along the bottom there, retail purchased pink shrimp have on average around 12.6 microplastics per individual, while vessel caught pink shrimp have around 11.9 microplastics per individual. And these are fairly small shrimp. Think about the first 2 digits on your pinky. So that's a pretty high amount per body size. We also see that retail purchase pink shrimp also had the highest number of microplastics per a single individual, with 36 microplastics in one shrimp, which is kind of terrifying. So next we'll compare our retail lingcod in light blue and our vessel caught lingcod in darker blue. We see that our retail species contain 7.6 microplastics per individual, while the vessel caught species contain only 3.9 microplastics per individual. So a pretty big difference here. And we even had one vessel caught individual that contained no microplastics at all. And so next we'll see the results of our black rockfish, brain fart, our retail purchase black rockfish. So due to demand of freshly caught black rockfish, we couldn't sample vessel caught black rockfish, but we were able to sample the retail purchase ones. So on average, black rockfish fillets contained 10 microplastics per individual, with 28 being the highest number found in a single individual or in a single fillet that you would buy at the store. So these are very popular fish to consume, and we expect similar results would be found across different rockfish species as well. So here are the results of our vessel caught Chinook, Pacific herring. So we have our Pacific herring, which were found to have 9.3 microplastics per individual, which comes out to about 1 microplastic per gram of tissue sampled. This is a small shoaling fish, so this is a relatively high number of plastics per individual seen here. And so now we have our vessel caught Chinook. So we were able to sample 10 individuals, and we found on average 5.4 microplastics per individual, which comes out to about less than 1 microplastic per gram of tissue, so about 0.8 microplastics per gram of tissue. And most of the Chinook we sampled were relatively large, around 8 to 10 pounds for the whole bodied fish. So these results are pretty interesting and pretty similar to other studies. So now we'll switch to our second research question, comparing differences in microplastic burden between 2 different life stages of Pacific lamprey. So for those of you not familiar with lamprey, they're born in rivers and then they swim out to the sea where they live for a period of time, and then they come back to rivers to spawn. So here we're comparing adult juveniles in blue and with the ocean phase adults in yellow. So the adult juveniles are the ones that are kind of just coming out to the ocean, whereas the ocean phase adults have been in the ocean for some time and they will be soon coming back into rivers to spawn. So we see that ocean phase adults have on average 15.9 microplastics per individual, and adult juveniles have around 7.8 microplastics per individual. But when we compare microplastics per gram of tissue, we see that ocean phase adults have about 0.6 microplastics per gram of tissue, while adult juveniles have around 1 microplastic per gram of tissue. This is pretty interesting, and I think further studies would be needed to really see why the differences in these 2 life stages are occurring. And so then to address our last research question, is there a connection between trophic level and microplastic burden? So first, comparing the retail species, we do see an inverse relationship between trophic level and microplastic burden here, with pink shrimp containing the most microplastics and lingcod containing the least. And we're probably seeing this increased number in plastics in our retail species just because of their exposure to plastic during the processing, for retail market and sale. And so comparing our vessel caught species, these results across all species and different sample sizes kind of mirror what we're seeing with our retail species, whereas trophic level increases as trophic level increases, we see a smaller amount of microplastics per gram of tissue. And even when we even out the sample sizes, we still see this trend across the species. And we're most likely seeing this kind of pattern just due to where microplastics filter out in the water column and proximity of the species habitat to pollution sources. And so now looking at the specific characteristics of the microplastics found, the most common morphology type was fibers, which is consistent with the current literature. If you look down at the shirt that you're wearing and you focus just kind of like along the edge of your shirt and you can see those small fibers coming off of it, this is kind of like the most common fiber size that you'll find, you know, throughout all of these fish and shellfish. And if you look here on the right, that's what those fibers kind of look like under the microscope. So we tested a subset of plastics for material type and found that the majority of our samples were anthropogenically impacted, meaning that they have some type of human origin of some sort. So for example, this would be a fiber made of cellulose that's been treated with chemicals like dyes or colorants. Synthetic and semi-synthetic plastics made up 31% of our sample size, which is higher than previous studies conducted here in Oregon on microplastics in muscle tissue of oysters. So the most common colors found were clear white fibers, followed by black and blue. So to conclude on our research questions, yes, there is a difference in microplastic burden between retail purchased and vessel caught seafood. Yes, there is a difference in microplastic burden between two different life stages of Pacific lamprey. And yes, there is an inverse relationship between trophic level and microplastic burden when studying Oregon seafood species. And so based on our findings, we recommend that we start studying how and by what pathways microplastics, specifically microfibers, are translocating to the muscle tissues of seafood species, or just species in general. We also recommend more studies measuring the effects of these microfibers, mostly on this species study here, but on a wide variety of species in general. And we also suggest that as a state, we start doing our part to prevent microfiber pollution. And as a result of this study and to be proactive researchers, another ACE-Lab member, Kier, has already started a study looking at the effects of several different microfiber types on California surf mussels from Oregon, which will hopefully lead to even more effects studies. And so I'd like to conclude by thanking everyone who contributed and made this research possible. Thank you to the Brander Lab at OSU for processing our FTIR samples. Thank you to the NOAA Observers Program for collecting all of the vessel caught samples, to ODFW's Lamprey Technical Working Group for all their insight, and to Oregon Sea Grant for funding this research. Also for all of the undergrads in our lab who helped process all of these samples. It was no small feat and they did a really great job.
Thank you both Maya and Summer for your fantastic presentations. There are a few questions in the chat and I'll go ahead and start with the first one. If anyone has questions for Maya, please enter those in the chat too, or feel free to raise your hand like we were doing earlier. So first question is, and I know there's an answer to this one, but was there any chemical identification for what types of plastics or microparticles were found in the organisms? And was it, I guess to add to that question, was it mainly microplastics or was it a mix of different materials?
Yeah, so there was a mix of different materials. Most of them, again, were those anthropogenically impacted fibers. And Suzanne, please correct me if I'm wrong. So these are mostly just fibers that have a natural origin, but they've been treated in a way that, could potentially still make them harmful to individuals. And then I believe we also found PVC, PET, and I think polyester and rayon material types as well.
Yeah, I don't have the results in front of me, but my recollection was that, like with other studies we've done here in rockfish and on zooplankton, we find about 25, maybe 30% synthetic, mostly fibers, be they polyester or rayon, or or actually that's semi-synthetic, or polypropylene, and then the probably about 50%, if I'm recalling correctly, were either semi-synthetic or anthropogenically modified cellulose. So probably something like, denim from somebody's blue jeans, for example. I actually had a really interesting conversation with Dr. Angie Durr. She's a fisheries extension specialist at Hatfield. And she was telling my class about the regulations in Oregon to use cotton ropes, specifically for Dungeness crab pots, and we were wondering whether that might be why we see a lot of modified cellulose in our samples from animals caught along the coast. So anyway, lots of additional questions to answer, but it looks like we have some hands up in the room. Catherine, I think you were first. Go ahead.
Thank you. Great talk, Summer and Maya. My question is for Maya. You mentioned that when you reached out to stakeholders, that there was this gap between them finding out the science from what we've done. And so I find that's like really common for a scientist. So from your work, do you have any insights into how we can bridge that science policy gap? Not just from us as science communicators, but also from talking to like the different stakeholders in like, do they have ideas of how we can reach out to them as well, or they can reach to us?
Yeah, thanks for the question. It's definitely something we've been thinking about as a follow-up to my project, is figuring out the best ways to distribute this information. We actually didn't really have any questions specifically to our stakeholders on what would be the best way to distribute it. But coming out of this project, it just seems like we could find some ways to either spread it via media or some other pathways. I think a follow-up project would be great to really find exactly what stakeholders are looking for and what would be the best format for them to receive information.
Thank you very much.
Lisa, go ahead.
Thanks. Both great talks. I had questions for you both, but since Maya, you just answered a question, I'll shoot one to Summer. I found it really interesting, the differences between the ocean phase adults and then the river phase for Pacific lamprey, with I think like around 1 per gram for the ocean or for the river phase, and then less than that, maybe half for the ocean phase. And I was wondering if you could maybe speculate on why you see that sort of difference. I know you mentioned more research may be needed, but is it the level of contamination between those two environments? I'm wondering if you just have any thoughts.
Yeah, so I really am not super sure, but if I had to guess, I would say like, yes, there is probably a difference in contamination between the two. But lamprey are really like long-lived fish. They live for a very long time. So I'm kind of just assuming that, maybe they pick up some in the river, they go out to the ocean and maybe just maintain that and gain some more microplastics. It's also, sorry, it's also pretty interesting because lamprey are not your common fish. They don't just, eat smaller fish or take in water. They suck on to other, fish and suck blood mostly. So that might also be a pathway. I think there's just a lot we don't know about them in general. And I think Elise has something to say.
Yeah, I just wanted to jump in. In the river, they're benthic. And so it may be that microplastics that are being deposited into the benthos onto the sediment, that they're more exposed to them. And so they have a higher load per gram of body tissue. And then as they go out into the ocean, they grow more, right? And so they may not be, they may or may not be losing microplastics that they acquired in the river, but they are growing in mass. So per gram of body tissue, there are fewer once they get to the ocean. But again, overall, there's a larger number, but they're also much bigger. There's a larger number in the ocean phase, but they're also much bigger there. I don't know, Lisa, does that kind of answer your question?
Yeah, I was wondering a little bit about feeding behavior too. Thanks,
Yeah.
that's fantastic. Thanks to you both.
Right, Brooke, go ahead.
Oh, sorry, I didn't hear you say me. All right, so I want to first say those were super interesting presentations, and I'm really, I kind of relay the sympathy of, I feel like we don't know that much yet. Like how in your presentation, you talked about how the stakeholders don't even know that there's that information out there. So I'm really happy to see that projects are being done on it. My question is for Summer, and you may have already spoken to this, but just in your opinion, where do we go from here as far as like policy changes, or as far as either preventing or removing the microplastics from the environments? Because it's pretty apparent based on your research and based on past research that they're pretty ubiquitous, and we're finding them in many, many samples. So what would you say is your idea of what we do next?
Yeah, that's a great question. You know, personally, I don't think we have the time or technology to go out and clean up the ocean. We barely know what's at the bottom of it. So I think the only feasible solution is to really prevent a continued influx of microplastics into the environment. You know, in France, I think it is, they have mandated kind of like filters or like catchment systems on washing machines to collect like microfibers,
Wow.
you know, off of like laundry. Yeah, it's pretty cool. So I think something like that, not necessarily, you know, saying like we need that immediately, but, you know, I think we just need to start looking into technologies that could limit the amount of microplastic pollution making its way out into the environment.
Definitely. Yeah, you spoke to the clothing as a major issue, which makes a lot of sense to implement that technology. Thank you. Yeah, and great work. That was excellent.
And Summer, there are a lot of questions in the chat, but a lot of them are converging on kind of the same type of question, in that, you know, did you see significant differences between the vessel caught and the retail? That it seems like there was a difference, but was a statistical analysis performed, or do you plan to do that with the data in the future?
Yeah, so I have actually just finished that statistical analysis this weekend, which was great. So there was a statistical difference between the retail caught and the vessel caught species across each. So running like the pink shrimp across pink shrimp, there was a statistical difference, and running ling cod against ling cod, there was a statistical difference. And then grouping, you know, both or all retail and all vessel caught together, there was still a statistical difference, a statistically significant difference across those two groups.
Okay, that the retail was significantly higher?
Yes.
What do you think might be driving that?
I honestly think it's probably just exposure to more plastic packaging. And it's, you know, while it's caught at the coast, and then, you know, it might be wrapped in plastic to the store, or it might be, you know, filleted and then wrapped in plastic and sent to the store. And, you know, it's sitting out at the fish counter, you know, microplastics might be falling on it, or something like that. I think it really is just a higher exposure to more plastic. And Elise also has some input.
And I do want to mention that in our protocols that Summer did rinse all of the samples, the outside of the samples. So anything that just landed in a fish market landed on them would have gotten removed. But, you know, fibers get wedged into things, right? And so we didn't scrub the outside. So if things got, you know, if there were microfibers and then someone handled them and it kind of mushed it into the fish, right, those wouldn't be removed. So
possibly just the multiple steps between when they were caught and when Summer received them and rinsed them could have exposed them to more than the fish that we got right from the NOAA fishing vessel. So yeah.
And there's a question for Maya here from Cynthia Kuhn, and she asks, were any of the stakeholders aware that microplastics pose multiple problems such as gill, intestinal blockage, desorption of chemicals, or was it just the term microplastics that caused their concern?
Yeah, thanks for the question. Good question. It really depended on the stakeholder. There's a lot of different awareness levels of microplastics throughout the people that I talked to. Talking about those specific issues like gill intestinal blockage, we didn't really get into the specifics of effects of microplastics. I did have a general question for stakeholders on their awareness of it to try to gauge where they're at with it. But yeah, so it was a little more general level to determine their concern level about microplastics.
Yeah, it's not too surprising. They might not be aware of the latest research, but yeah. And then Lauren asks, and this is going back to Summer's presentation, did you see any correlations between plastics found in plastic packaging or bags that they may have been purchased in? And I don't think we did, but Summer, I'll let you go ahead and answer that, and I can follow up on FTIR if need be.
Yeah, so we didn't necessarily look for that, but over 90% of the plastics that we found were microfibers, and so not the type of plastics that you would see from the plastic packaging that we received the food in. Most of the fillets were just, kind of in those, butcher bags, and then like a plastic bag, the kind that you put like vegetables in and stuff.
Summer, were the butcher bags made of that like coated paper? Okay. Yeah. My recollection is that we really didn't see a lot of either high density or low density polyethylene in the FTIR results. So yeah, like you're saying, it was mostly fiber contamination coming from elsewhere rather than from the packaging itself.
I think PET was the highest among the synthetics.
Yeah, the polyester. Yeah.
Yeah.
Mm-hmm. Yeah. Question for Maya. It says, with the lack of knowledge from the stakeholders regarding microplastics, do you think that is due to poor science communication, technical language, or other issues being perceived as more important? Fish stocks, climate change, what have you? Really good question from Catherine.
Yeah, very good question. I think talking to interviewees, we had that question on ranking other marine issues compared to microplastics. And we also discussed in the interviews a little more in depth about what people viewed as most important. And we are seeing some other issues as being perceived as more urgent than microplastics at this time. So there are a lot of threats to the marine ecosystem right now. And some stakeholders were seeing other problems as getting more priority up over microplastics at this time. In my opinion, it does seem to be a communication issue as well of scientific findings to the greater public. I think hopefully we can find a better way to distribute information to the general public.
Yeah, and I'm seeing some comments in the chat about washing machine bills, since we're talking so much about microfibers, and I know with studies that we've done, it feels like we're more doing microfiber research than general microplastic research sometimes. And there are several washing machine bills that have been introduced in Ontario, California, as well as the United Kingdom, and then one that was recently passed in France. So this is a comment from Lisa Ertel, some changes on the horizon there. And lots of thank yous for great answers to questions. Does anyone else have questions for Maya or Summer or Elise? And the California washing machine bill, to my knowledge, has not passed yet. I think this is try number 2 or 3 at this point.
Yeah, it was just introduced this session. I think for the second time.
Okay, cool. Fingers crossed. Bob, go ahead.
Hey, thank you, Suzanne, and thank you, Summer and Maya. That was great. I have a question for Summer or whoever. I'm interested if you have data on how much microplastics are in other types of food besides seafood. For example, how much microplastics are in a gram of a hot dog? Just to put some of these data in context. And then the other thing is bioaccumulation. What's more important, the feeding behavior or the trophic level, and how they would come in contact with the plastics?
Yeah, so I can't give or I can't remember the specific numbers for studies, but we found microplastics in a range of different things: honey, beer, salt. I think there's a study, I think it's an ongoing study or a study that's going to take place on beef soon or something like that. So we really find microplastics in everything. And maybe Elise, do you remember some of the numbers on those?
Yeah, I mean, I know that, for example, in your bottled water, if you buy bottled water, it's an order or two of magnitude higher than in your seafood. And similarly, what was the other thing I was just thinking of that has really high levels? It just left my brain. But anyway, yeah, seafood ranks pretty low relative to some other sources. To breathing it in. So we breathe in more, we get more. And tea bags. So synthetic tea bags and bottled water all have really high concentrations of microparticles relative to seafood. There's been some work on vegetables, and we see microplastics inside vegetables, inside the tissue of vegetables and fruits. To my knowledge, none of the study, I know as Summer mentioned, there's some ongoing research elsewhere on microplastics in other land-based protein sources. I have not seen anything published yet. I don't know, Suzanne maybe has seen something, but I haven't seen any of it come out yet. So I think most of that is still in the works. But yeah, I think one of the things that we try to communicate in our work is that, the answer isn't, oh, you should stop eating seafood from the Pacific Northwest, because relatively it's not the biggest source of microplastics that you're taking in. You're taking in a much more microplastic, potentially from your drinking water, if your municipality gets it from river water that's downstream of other municipalities, and just from breathing the air. So really the solution is that we need to address sources, not that we need to change our seafood consumption, because that isn't going to probably dramatically reduce your exposure. Although I think it is worth mentioning that, some of the species that we were looking at are species, are first foods for tribal communities in Oregon. And so they may have much higher consumption of things like lamprey than others. And so thinking about that exposure risk, I think, is important sort of in our broader consideration of how we manage sources of microplastics into our waters. But again, not as sort of a restriction that people should be limiting their seafood consumption, because that will only eliminate one of the many sources that are exposing us to plastics. That was a great question, though. Thank you, Bob.
Yeah, and just to follow up on that, the most recent study I'm aware of that's out of Europe, out of Bart Coleman's lab, estimated that air is you get a higher exposure from the air than any of these other categories: seafood, drinking water, other types of food, etc. So.
Okay, great. Oh, and what about the trophic transfer versus feeding behavior? Shrimp feed differently than fish. And, you mentioned the lampreys. So I was just interested if we know enough about that.
No, go ahead, Summer. You want me to go? Okay. Yeah, I do think from the data, so there's some data out of the Great Lakes, out of, I know Chelsea Rockman's lab and others, that indicate that lower trophic levels seem to have either that there's no pattern with trophic level or that lower trophic levels seem to have more microplastics than higher trophic levels. But those trophic levels are also correlated with feeding modes, as you know. And so my hypothesis would be that feeding mechanism actually plays a bigger role than trophic transfer. Not to say that there's no trophic transfer, but that acquisition is probably more associated with feeding mode. I don't know, Summer or Suzanne, I don't know if you guys want to add anything to it.
So would you suspect that like baleen whales, would have much higher exposure than toothed whales, for example?
Probably. Suzanne's doing some work on whales and microplastics. I might defer to her on that one.
Yeah, we're doing some work in collaboration with Lee Torres's group, the GEM Lab here at Oregon State, looking at gray whale exposure, and they primarily feed on zooplankton, so mysid shrimp, tiny little gammarid amphipods. And because they have such a high rate of consumption of these lower trophic level organisms, it is possible their exposure would be higher than, say, a tuna that's eating larger fish species that might not be consuming. They have a more direct line to that lower trophic level that is ingesting higher amounts of microplastics. But we're still quantifying what that exposure level is. So more soon. Go ahead.
And I just wanted, and also in response to Bob's question, I just wanted to point out, Summer sort of mentioned it, but I really wanted to highlight that what Summer was looking at was only consumable tissue. So in the shrimp, their guts were removed. In the herring, the guts were removed. And the tissue we were looking at in salmon and lingcod, for example, were just the consumable tissue, right? So I think, a lot of studies have looked at microplastics in guts of fish. But there's, I think until the last maybe year or so, there's been this assumption that there's not actually like transfer within the organisms from gut to tissue. But what we were seeing is that actually there's perhaps because the smallest dimension of these microplastics, although many of them were 100 to 500 microns in length, the smallest dimension was under 20 microns, and that small diameter allows them to translocate from the gut into the tissue. And I think it's really important that we recognize that, because although there's, as we all know, there's so many effects of having microplastics accumulate in your gut, there's probably also likely some significant effects of having microplastics translocating into tissue. So sorry, go ahead, Suzanne.
Okay,
it looks
great.
like we're
Thank
just thank you, Elise and Summer and Maya. It looks like we're just about out of time, but there is one more question from Catherine. Catherine, it looks like you have your hand up. Go ahead.
Thank you so much. And this might be too long of a question, but Summer, can you talk a little bit about where your samples were collected? For example, were they collected on the coast, and what about the retail products? Do they have a country of origin? Because I did work with black rockfish, albeit their GI tracts in Oregon, and could see a locational difference between my northern sites and southern sites.
Yeah, so all of the vessel caught species were caught somewhere along the Oregon coast, close to the coast and a little bit further out. Those locations are not specifically like grouped by like northern or southern or anything like that. They're from all along the coast. And then the retail purchased species were bought, some were bought from seafood counters near the coast, and some were bought from seafood markets or even wholesale markets, kind of, like a Whole Foods or, like a Safeway here in Portland.
Thank you.
Great. Well, thank you so much to everyone who presented from Portland State this morning. Thank you for spending the time to tell us about your research. Why don't we take about a 2-minute break, and we're going to transition to UW Tacoma and Julie Masura's group there. So thank you again. Hopefully everyone is back from our quick break. I'm really excited to welcome Julie Masura and her research group from UW Tacoma, and they're going to be talking about some long-term microplastics analysis work they've been doing in the Puget Sound. I'm so really excited to hear more about this work, and I'll let them go ahead and take it away.
Thank you so much. There's going to be 4 presentations today. I'm going to go ahead and give a little bit about the scope of our lab and what we've been doing at the University of Washington Tacoma. And then we will have Caitlin presenting on our partnership with the Washington State Department of Ecology and the work that we're doing with them. Abdul is going to talk about our methods and share his, we'll be sharing his slides on methods development. And we wanted to really highlight the work that he has done with putting together some fabulous diagrams that we wanted to share. And then Maggie Jo's going to wrap this up at the end and talk about the project specifically. So I am Julie Masura. I'm from the University of Washington Tacoma. I'm an environmental science faculty member with the School of Interdisciplinary Arts and Sciences. I run a research lab of mostly undergraduates, a few graduate students, and really am committed to experiential learning at the university. So the University of Washington Tacoma, why here? You know, why did it end up here in the Pacific Northwest? Well, we were the first to host the plastic marine debris workshops in partnership with NOAA's Marine Debris Division. We hosted the first one on our campus in 2008, and then a few years later, we hosted the second one at our newly made Center for Urban Waters in downtown Tacoma. Since that time, we've engaged with over 54 undergraduate and graduate students have come through and has contributed to some of the work. And actually, there's a number of students who've contributed to the work we're going to talk about today. Our partnership includes over 20 local, national, and international groups. I get phone calls all the time, which I'm sure most of you probably do also, getting some advice, sitting on graduate committees, doing talks like this. So we've got some wonderful partnerships that have been developed over time. This is just a quick, I love to kind of share a little bit of the history, just looking at the logos for some of our partners. And this is not all of our partners, but up in the upper left, this is Tacoma Community College. They do a climate change and pollution courses. And so we'll take their students out on the boat and teach them how to do some environmental sampling and doing some really rudimentary analysis in their labs. On the right, that's Bellarmine Prep. Bellarmine Prep is a Catholic preparatory school in which we have students coming in and out of the lab doing some really great, wonderful, creative research projects. North Seattle Community College is one of our initial partners. I used to work there and then I moved to UW Tacoma, so I had some colleagues there that we continued some partnerships. I have the Seattle Aquarium here. Lida, good to see you. But we've done some work there. We've also just had some wonderful collaborations there. The United States Geological Survey, both national and local. The water group is just down the street from us. But we are, and actually I won't spill too much of the beans, but Caitlin's going to talk about her work with USGS. Washington State Department of Ecology, that's the focus of our talk today. I'm going to skip sound experience till the end. The sea is not the national sea, but this is the Sea Education Adventures out of Whidbey Island and done some teacher collaborations with them. I've sat on some graduate committees at Oregon State, of course, NOAA's Marine Debris Program. Jason Lee Middle School just down the street, they're doing a name change, which is exciting, about diversity and equity. That's a whole nother story, but we have middle school students that we go out and do some beach plastic work. Sea Grant through the University of Washington, but also Hawaii Sea Grant. We did some work looking at plastic fibers and feces of mammals. This was really the hardest position for me to be in, but I had to do some work in the Virgin Islands. So I had an opportunity to do some research in the Virgin Islands, which was super exciting. Of course, we are initially associated with the Center for Urban Waters, and that's where we kind of started, and we're back to the University of Washington Tacoma, just a couple miles away. And then an interesting and really fun project is working with NSERC. This is Canada's equivalent to the National Science Foundation. Women scientists going out to First Nations community and teaching about many aspects of science. And of course, marine debris is one of them. Academic contributors, Bellarmine Prep, as I said, North Seattle Community College, the University of Washington, Seattle, of course, the University of Washington, Tacoma, and we've done some I've had some discussions with some researchers about collaboration with Western Washington University. So as I said, well, I may have said, mostly the students that are in the lab that I actually oversee are undergraduate students. And so we have had a couple or handful of graduate students coming through that work physically in the lab or works in collaboration with the data that we're collecting. One of the ongoing graduate student projects, we have our Department of Urban Studies has a geographic information systems master's program. And so these students actually created basically this map where each dot, and you'll notice that the dots here go all the way up and down the west coast of Vancouver Island, which is the research that I do looking at ocean properties. And then of course, throughout the Salish Sea and mostly focused in the Puget Sound. You click on a dot, it tells you how much plastic's in there. It also has a sample ID number that's associated with the sampling of the samplers. One of those dots that's on there, as if you guys do field work, can take up 8 hours to collect, right? So if you're out there, you're prepping your prepping your equipment, you go to the ship, you get out in the ship, you collect your samples, you come back, you clean everything up. It's quite a load. And so the partnerships that I've been able to develop have helped to contribute to doing the collection and bringing the material to our lab in which the undergraduates and graduate students can process for this map. I'm not going to read all this stuff off, but these are some past projects, but some highlights is looking at marine debris in St. Thomas and the Virgin Islands. We actually had a group of 2 girls that actually did the race to Alaska, which is on only manpower, no mechanical power. And so they went up and they collected samples on their way up. We also looked at exposure of northern fur seals throughout the Circum-Pacific. And looked at and continued to look at some of the plastics in the surface waters, the Gulf of Alaska, and that was a collaboration with NOAA. So what we're going to focus on today is looking at the distribution of microplastic debris in Puget Sound sediments. And so that's what we're going to do to wrap up our talk today. We're still actively working on the spatial and temporal distribution of microplastics from 2008 to present. The ongoing collection due to the education and outreach, we continue to collect that material and add it to our large data set. I was just kind of looking at my CV and I'm like, how many projects have I done? So I created this bar graph just to kind of show you kind of the amount of projects that are happening in our lab per year. And so it first started out with 13 students. And you notice that we actually, or 13, or three projects. And you notice that we actually spiked in 2021 during the height of the pandemic to 13 projects and 13 individual students working in the lab, which just means that we had some time to do some analysis. Though the whole entire country shut down, our labs were not shut down at the University of Washington. We just had stronger protocols, less people in the lab at the same time. So we're actually able to do a lot of stuff and to pump out some samples and some projects, which was really kind of exciting. We have a little bit less this year, but I just met with 2 students yesterday, so I'll bump that number up in a bit. Don't worry, Maggie Jo, I'm not going to talk about this. Maggie Jo is going to share with you one of the ongoing undergraduate projects that we started in 2000. Well, we were looking at sediments going back to 2014, and we'll actually update you in more detail about this project in just a little bit. I'm going to leave you with just one kind of great opportunity that we have with our students that work in the lab is we do a ton of outreach. Anytime someone asks us to do a talk, I always have students going, yeah, I'll do this. In fact, 2 of the presenters today have already graduated. So they're like, yeah, I'll go ahead and skip work this morning so I can do this presentation, because it's really important to do the outreach, to be able to communicate what you do. This is the Girls at the Helm. I'm not going to say much about it, except this is an all-girl cruise that we take out on the historic schooner Adventurous, and this is through Sound Experience. Sound Experience is an environmental outreach group, and we basically talk about many different science issues, and marine debris being one of them. And 2 of the presenters today have been out on this cruise. We also have done a ton of podcasts and lots of stories that have happened in the popular news. So I'm going to go ahead and stop talking about how cool and what a great opportunity it is to work in the lab. And I just wanted to show you a list of all of the students who've come through the lab so far. And the bold and the larger ones are 3 of the presenters today. We're going to start with Caitlin, and then Caitlin and Maggie Jo are going to tag team to present Abdullah's work. He prepped the presentation. He was unable to present today. And then Maggie Jo is going to wrap up with talk about the research. All right, Caitlin, you're up.
All right. All right. Hi, everyone. My name is Caitlin Mcfarland. I am a researcher and an alumni of the University of Washington Tacoma. I also work at Seabird Scientific, which is a company that creates oceanographic research sensors as a CTD and glider test technician. Today, I'm going to be talking about UWT's partnership with the Puget Sound Marine Ecosystem Monitoring Program. So as a quick overview, I'll be giving a brief introduction to my work at the University of Washington, including my involvement in the UW Oceanographic Lab and in marine monitoring research. I'll talk about a couple projects and partnerships that I've had the privilege of participating in. And then I will go on to talk about quickly my introduction to microplastics research and some of the current work that I'm doing. After that, I'll switch gears and talk about the partnership with the Washington State Department of Ecology and the Puget Sound Ecosystem Monitoring Program, or PSEMP for short. So I started working at the University of Washington in 2017 with sediment and estuarine monitoring research. My research has focused mainly on harmful algal blooms, specifically Alexandrium catenella, sorry about that, a dinoflagellate that creates saxitoxin, which can cause paralytic shellfish poisoning. I've been involved in a handful of sediment-based research projects, including Alexandrium research in Elliott Bay with King County's Marine Monitoring Group, in Port Gardner near Everett, Washington, which is just north of Seattle, and with the Puget Sound Ecosystem Monitoring Group. And then I've also participated in a study with NOAA, the University of Washington, and the University of Alaska Fairbanks in the application of quantitative molecular methods to characterize the abundance and distribution of Alex cysts for NOAA's harmful algal bloom forecasting. I've also had the opportunity, as Julie hinted, to be involved with microplastics research through a project with the U.S. Geological Survey. And that project followed the 150th anniversary of the J.W. Powell expedition that went through the Grand Canyon to determine if microplastics are present in the bed sediments along the Colorado River. For some future work, I will be presenting at the Salish Sea Ecosystem Conference next month on some of my research done in Port Gardner from 2019. So for microplastics work, most of my microplastics research involvement has been through public education and outreach. I've spent a lot of time on boats sampling for microplastics and other sediment samples. I mentored aboard the schooner Adventurous as a woman in science mentor through Sound Experiences Girls at the Helm program mentioned by Julie just prior. And there I talked about microplastics identification and performed the methods for sampling in the water column using a manta net. I have been featured in a few podcasts like the Voices Unbound podcast that was on one of the previous slides, and have contributed to a few talks to university students on microplastic research in the Salish Sea. I also have participated in multiple talks about plastics for seminars, and at the Seattle Aquarium, I got to help alongside Julie to introduce microplastics to youth that were there. I've also assisted in field sampling of both sediment and water microplastic samples, and currently I'm wrapping up the Powell expedition research. As Julie mentioned earlier, the Puget Sound Ecosystem Monitoring Group collects benthic sediment samples throughout Puget Sound, and they do that at 50 long-term monitoring locations. Just kidding, sorry about that. Scratch that. So, sorry, I wanted to talk about the reason as a former student and now a researcher, how I and many others at UW have had the opportunity to do research involving bed sediments and microplastics throughout the Puget Sound region. The Puget Sound Ecosystem Monitoring Program is a group of various organizations that come together to support the health of ecosystems throughout the region. There are many major variables in the overall health of the ecosystems in Puget Sound, such as ocean influence, estuarine water circulation, seasonal changes, and depths that range from 5 to 300 meters. The image there is an example of circulation patterns and sills throughout the sound. Anthropogenic changes are also a very large factor in ecosystem health and are becoming a more prevalent factor in current research. The purpose of the project is to monitor for long-term patterns and short-term changes within the various water bodies and to assess the health of the sound. The Department of Ecology has a quality assurance monitoring plan that outlines the yearly long-term and urban bay monitoring that they complete each year. And now I'll go back and say what I said earlier. As Julie mentioned, the monitoring group collects benthic sediment samples throughout Puget Sound at 50 long-term monitoring stations. The long-term stations are in the yellow highlighted region on the map on the right. The yearly rotation with a more in-depth sampling of 6 urban bays occurs in the areas highlighted in red. And these include Bellingham Bay, Port Gardner, Elliott Bay, Commencement Bay, Bud Inlet, and a grouping of inlets near Bremerton and Port Orchard that includes Dyes and Sinclair inlets. In 2021, Elliott Bay, circled in green there, was the chosen of the 6 urban bays and was the last set of samples examined by the University of Washington from the Department of Ecology. To collect these sediment samples, a Van Veen grab, which is pictured there in those 2 images, is deployed on a research vessel to grab the first 1 to 3 centimeters of sediment. The samples are then sent to the University of Washington Tacoma to complete various sediment analyses. So the University of Washington Tacoma has partnered with the Puget Sound Ecosystem Monitoring Group and the Department of Ecology since 2014. Though the group itself has monitored Puget Sound since the mid-1970s. PSEMP's sediment work began in 1989, and the University of Washington's contribution consists of harmful algal bloom quantification, total organic content analysis, particle size analysis, and microplastics quantification, which we will get into a little bit more detail in just a moment. After the lab analyses are completed, the data is then sent to the Department of Ecology for their yearly reports and publications. These yearly publications are produced through this collaboration, and they show the changes within the water bodies in the sound and can be used in comparative studies. The collaboration of the Department of Ecology and the University of Washington, with the collaboration of the Department of Ecology, the University of Washington has been able to have a database of yearly data points on microplastics quantification in this region since 2014. And with that, I'm going to switch gears to talk about the methods that we use.
I'm going to project that, right, Caitlin?
Yes, please.
Okay.
All right.
Okay.
Thank you. All right, so with help from Maggie Jo, I'm going to be presenting the work put together by Abdullah Alamar on the methods that the University of Washington Tacoma uses for isolating microplastics from seabed sediment samples. So the purpose of the microplastic analysis done at the University of Washington is to isolate microplastics from benthic sediments to then quantify and map the distribution of microplastics in the Salish Sea. The methods used help determine a count, which can be mapped like on the heat map on the right. And this one was from work completed in this study that Maggie Jo will go over shortly. This image is from 2014 to 2019 at 10 stations throughout the Sound, and it shows a range of microplastics per square meter. The laboratory methods that we use document type, size, and color of microplastics found. A blank is run periodically to determine any cross-contamination within the lab and our samples. And then the mapping is used to observe change over time in the distribution of microplastics. Next slide, please. All right, just to reiterate for a couple people who may not know about microplastics, but I'm sure most of you do. Microplastics vary in shape, color, chemical composition, and density. There are two main categories of microplastics, primary and secondary. Primary microplastics are those that have been produced as microbeads or pellets. These are also called pre-production plastic pellets, little tongue twister there. And these are used as the base materials for larger plastic products. Secondary microplastics are plastics that have been fragmented from either chemical or photo degradation or from mechanical weathering. The four main types of plastics that we find are characterized by size. 0.91 to 0.97 grams per milliliter is polyethylene. 0.94 grams per milliliter is polypropylene. And then 1.05 grams per milliliter is polystyrene. And lastly, 1.4 grams per milliliter is polyvinyl chloride. Can you go back one really quick? Thank you. The image on the right is an example of some plastic fibers found in research from the partnership with PSEMP. And this is at 40 times magnification. Now you can go to the next slide, please. So the sample processing starts when the samples are received from the Department of Ecology. They go through about 5 main steps to separate the microplastics from the sediment samples. It starts with a disaggregation of sediment, and then a density separation of finer sediment, an oxidation process for organic content removal, a second density separation, and then lastly, a microscope exam to then use to determine the abundance and persistence of microplastics in the sound. And with that, I'll pass it over to Maggie Jo to talk a little bit more in depth about each of those steps.
Hi, Julie, you can go to the next slide.
Okay, thank you.
Okay, so this is part of the series of these beautiful graphics that Abdullah made for us to kind of show in more detail our processing. So the first step in the chemical processing is disaggregating the sediment sample, and we use a potassium metaphosphate solution. So the sediment is mixed for an hour in the solution, which just kind of works as a soap in order to break up the particles and release any microplastics that might be stuck in the sediment. We then run it through a 0.33 millimeter sieve and dry the sample. The 5 millimeter sieve is used prior to the smaller sieve when we have samples that maybe have larger rocks or seashells or other marine debris. We then take the dried sample through a series of density separation techniques. So we use lithium metatungstate, which is a high density solution at 1.6 grams per milliliter. And that's used to float out the low density plastics, which then collect at the top of the solution. We can then pour off the supernatant again through a 0.33 millimeter sieve. And we use that lithium metatungstate specifically because it's easily recycled. We can just evaporate off any extra water to reach the desired density after it's used. After that, we dry the sample again and take it through a wet peroxide oxidation. So we put the sample in 30% hydrogen peroxide using ferrous sulfate as a catalyst and let that go on a stir plate at 75 degrees Celsius. And this process is to get rid of the organic materials to make it easier for inspection later. And then we do this oxidation process at least 3 times to get rid of all that organic material. Next, we increase the density of the solution again by adding sodium chloride, again, to float out any potential plastics. Allow that mixture to sit in a density separation apparatus. And that's for at least 8 hours. And then once that's settled, you can see the heavy solids are at the bottom, that gets discarded. And then the supernatant is again collected and put through a final examination sieve. So that's a process of how our sediment samples go from our sample jars to the final sieve. And then we use a dissection scope. You can go to the next slide. A dissection scope, again, at 40 times magnification, and then we manually collect plastics and store them in these glass vials for mass collection and future potential FTIR spectroscopy. So that's it for the processing and methods. I'm going to go ahead and take over for my portion. Okay. Okay, so just a formal introduction. My name's Maggie Jo. I'm going to go over the most recent results from UWT's microplastic exploration in Puget Sound and kind of talk about also the long-term plastic research that we've been involved with PSEMP. So I obviously am a UWT environmental science alum. I first got involved in microplastics research in 2018 when I started my capstone project with Julie. From there, just got more involved with different projects in Julie and Cheryl Greengrove's oceanography lab. And I have experience in kind of every part of the process with microplastics in sediments. So I've had the opportunity to sample. I had experience in processing the samples, data analysis, and then actual communication of the data to different groups, whether that be government agencies, other marine scientists, local tribes, community members, students, etc. During my undergrad experience through working with Julie, I've also had multiple opportunities for volunteering as a science educator and mentor, and kind of teaching about microplastics. So I got to volunteer for the YMCA Earth Service Corps. We did a microplastics workshop for their environmental symposium. We also did a workshop with students from the Tacoma School of the Arts, and actually got to go out and sample on their research vessel for their environmental science course. I've also been on a few cruises for the nonprofit that both Julie and Caitlin have mentioned, Sound Experience, and specifically was involved in the Girls at the Helm program. Just to recap, it's the educational cruise. They take out a group of all girl students, all female identifying crew and mentors, and just, teach everyone how the ship runs, but also using the opportunity to promote marine ecosystem knowledge. So I got to do some microplastic education and show how we conduct water sampling and some aspects of the processing. I also had the opportunity to be a student researcher and teaching assistant for projects conducted at the Center for Urban Waters. So I got to show students who are new to microplastics research how to process our samples. I also presented my microplastics research at a conference in Hawaii, and this was for the Society for Advancement of Chicanos, Hispanics, and Native Americans in Science. This was for their Diversity in STEM conference. My team's work has also been published in the Puget Sound Marine Waters report that Caitlin mentioned. So the yearly report comes out through the PSEMP partnership with the Department of Ecology that monitors and assesses the state of Puget Sound. So since graduating, I still help out with microplastics research for PSEMP. I've had the opportunity to help train new students coming in, working on their capstones, teaching them how to process and analyze sediment samples of microplastics. A few of the photos here are actually from a recent research trip that I went on with Caitlin and Julie a few weeks ago. And then some upcoming stuff. My microplastics work with Julie is going to be presented also at the Salish Sea Ecosystem Conference in April. And then Julie has been presenting our work at the Ocean Sciences meeting that's been occurring this week. Okay, so as Caitlin mentioned, Department of Ecology samples yearly 50 stations in Puget Sound and then rotates sampling of one of 6 urban bays. So there's one in Olympia, Tacoma, Seattle, one off Bainbridge Island, Everett, and Bellingham Bay. In 2021, they sampled Elliott Bay. So here's a zoom in of Elliott Bay, Seattle here, and then the Duwamish River coming into the bay here. Department of Ecology got 37 sediment samples this year, and they were processed and analyzed by current environmental science students. And one of them is the one who made this heat map here. And then just to orient, Seattle and the Duwamish coming in and then heading out to Puget Sound. So this heat map is showing the abundance of microplastic pieces per square meter of surface sediment. The highest concentration was found at station 188, which is here, with about 16,000 microplastics per square meter of surface sediment. The lowest was found here at station 174, and that had 318 microplastics per square meter. The average was about 5,000 microplastics. You can also see somewhat of a trend with the abundance being greater near the shoreline with these darker circles, and then decreasing as you go further out into the sound.
We've got about 5 minutes, Maggie Jo. Yep. Thanks.
Okay. So this Urban Bay data is part of this greater collection of data that the Department of Ecology has been collecting since, or we've been processing since 2014. And this time series is showing the data from 10 long-term monitoring stations from 2014 to 2021, except for 2020. We have no data because no sampling happened due to the pandemic. And we're measuring in the same units microplastics per square meter of surface sediment. And I'm just going to go back and forth between this and the next slide. So the minimum number of microplastics found was 0 in one station in 2017. So that was this station here. So this is the only station in any year that we didn't find any microplastics. The average is about 3,500 microplastics per square meter. The maximum was also found at a station in 2017 with 27,000 microplastics, and that's this station here. The lowest year was in 2019 with 681 microplastics per square meter. And then the highest year was actually the first year of sampling here in 2014. And although it looks like the abundance is less each year after conducting statistical tests, we don't see statistical significance in the decrease. Lastly, characterizing microplastics, we, like Caitlin said, we look at type, size, and color. The majority of what we find in Puget Sound are fibers, followed by fragments at 4% and films being only 1%. The majority of these are 1 to 2.5 millimeters in size, and most are either colorless, white, or black. And the big takeaway here is that microplastics are in Puget Sound, and not only are they present, but they're persistent. This makes us consider the implications of this on marine health. And although the number of plastic particles for this project seems like it's decreasing each year, there's no statistical evidence that these numbers represent a significant change in plastic pollution over time. This is why we need to continue monitoring these bed sediments and why it's important in understanding the possible exposure to organisms in the Salish Sea's benthic ecosystem. Especially considering the amount of ecosystem services that our estuary provides. Some future work or considerations, looking at anthropogenic activity, also looking at the presence of wastewater treatment plants, the type of sediment. Do we see more microplastics depending on how much organic material is in the sediment? And lastly, is there a difference in microplastic distribution depending on the season? But overall, we hope that this work will contribute to future microplastic mitigation and restoration in efforts in different estuaries around the world.
Thanks, Maggie Jo. If you guys are, Caitlin and Maggie Jo, comfortable to turn on your cameras, we can address some of the questions for these guys.
Yeah, and thank you so much to all three of you for your presentations today. It's so great to hear about the work going on in Washington State. And I did have one follow-up question to my question about the distribution of polymer shapes. Since you are finding mostly fibers, like, most of the studies right now are finding in terms of occurrence, do you see a distribution of synthetic types, say polyester, in addition to semi-synthetic and anthropogenically modified fibers, like anthropogenically modified cotton, for example? Or just curious as to whether what you're seeing matches with what we've been observing in biota.
You guys, do you want to? We actually don't have the capacity to do that analysis part. So the work that we're doing is visual, and that always, time and money, right? So really it's visual, and it's the opportunity to get students in to see. But we're very confident that, that they're not fur seals. I've seen a lot of fur, and it's very, very different. I mean, you can see that inspected. But, Maggie Jo and I have talked about, getting in and getting the FTR out and doing that work. But no, we're just doing it visually. Yeah.
Very cool. And I'm assuming it is not fur seals. I'm sure it's all human derived for the most part. And if you ever want to send us some fibers, just let me know. We can zap them for you.
Awesome.
Catherine, go ahead.
Thanks, really great talks. My question's for Maggie Jo. It looks like there are quite a distribution in terms of microplastic levels that you find around the sound and sediment samples. And I'm wondering, have you looked at whether there's any relationship between recent storm events or scouring events, or even maybe contributions coming from stormwater or other outfalls?
Yeah, so we haven't looked at that specifically, but I mean, as I mentioned, in terms of distribution, depending on the season, we definitely, like, there's physical changes going on in the Puget Sound depending on the weather, and that definitely affects the movement of the sediment. So yeah, I would definitely guess that that's happening. But yeah, I think that would be cool to look at. We just haven't specifically looked at that.
Cool, thank you very much.
And just a few additional questions in the chat.
Can I follow on just really quickly? Is we're restricted to the Department of Ecology, who only samples for us in June. So that's another thing. So we don't look at those things, but yeah, go ahead, Suzanne.
No worries. Someone asks, at what depth did you get your samples? And you already talked about what types of microplastics you found to some extent, but what depth are you generally sampling at?
So throughout Puget Sound, it varies between 5 and 300 meters. So every station each year actually changes as well due to kind of ocean flow or any anthropogenic activity. So anywhere between 5 and 300 meters for these samples.
Nice. And then Heather Trim is asking, what do you do to eliminate contamination from the lab, from fibers floating around in the air? I know that's something we're challenged by here too.
I can take that one. So while we are running our samples, we periodically run a blank to make sure that there's no contamination within the air, because we have found fibers in other studies that are in the air. And while we're doing our picking work with the microscope, we have a slide that has a piece of cotton on there to catch any fibers. And then what we do is, if there are any on there while we are counting our samples, we subtract that from the total count. So to kind of determine any error or potentially contamination from our own clothing.
Nice, nice. And we are running a little bit short on time, so I'm going to cut the questions off there. And there are a few more in the chat, but if you get a chance to answer those in the chat, that would be awesome. Or we can bring them up at the end if we have extra time at the end. But thank you so much to all of you for your presentations today. Next, we're going to be switching back to folks from the Pacific Northwest Consortium. And we'll be starting with an update from the Harper Lab from graduate student Brittany Cunningham, who's a PhD student in Stacey Harper's lab. There will be one talk that we won't be hearing today. Dr. Siddiqui had to drop out for the morning, but we'll also be hearing from Emma Sharpe, and then Dr. Wayne Landis will transition us into talking about future directions and getting us into breakout groups. So Brittany, go ahead, take it away.
Thanks, Suzanne. As you can all see, I'm in the lab right now. So I'm actually going to play you a recorded video of a presentation I've made about our tire particle research, but then I'm very happy to take questions live after that. So let's see if I can get this to work.
Hello, my name is Brittany Cunningham. I am a graduate student at Oregon State University, and today I will be talking to you about the differing toxicities of micro and nano tire wear particles and leachate to the development and survival of zebrafish and Daphnia. To begin with, we'll discuss some background on plastic pollution. As many of you know, production of plastics continues to grow, and with it the amount of plastics flowing into the environment. We traditionally classify plastics by their size. Those greater than 25 millimeters are macroplastics, those less than 5 millimeters are microplastics, and those less than 100 nanometers are nanoplastics. Such plastics may be created at micro and nano sizes, those are from primary sources, or may break down into those sizes from larger plastics such as water bottles. These are from secondary sources. Plastic particles have been observed in the environment and organisms all around the globe, and as these micro and nanoplastics are characterized, they have been found to cover a diverse suite of sizes, shapes, colors, and compositions. For example, a study by SFEI documented plastics in water, soil, and fish in the San Francisco Bay Delta. They found that fibers were the most common shape, with fragments in second. One commonly noted fragment type was black rubber, or tire particle. Other studies have documented tire wear particles in environmental samples as well. You'll see this abbreviated as TWP throughout this presentation. Attempts have been made to model and quantify the flow of tire particles into the environment. It was estimated in 2017 that on average the U.S. generates 1.5 million tons per year of tire wear particles. The consequences of the addition of tire particles to the environment are not fully understood. Past research has mainly focused on the toxicity of tire leachate, ignoring potential effects related to the particles themselves. With these research gaps in mind, we designed experiments to assess potential particle and/or chemical toxicity of micro and nano tire wear particles to two model organisms, Daphnia and zebrafish. As we set out to investigate the toxicity of micro and nano tire wear particles, the first step was creating particles in the sizes we needed. This slide details methods developed by Brian Harper in our lab that takes larger macroplastics and breaks them down into the micro and nano sizes that we want to test. Feel free to pause the video and read them more carefully if you would like to. For these experiments, we made particles with the tread of a new undriven tire. These particles were then separated into the size categories we wanted. Particles between 1 and 20 microns are micro tire wear particles, and particles less than 1 micron are nano tire wear particles. Additionally, leachate was created in the exposure media, either fish water or Daphnia water, of the organism. Now, I'll first cover the assay and results of zebrafish toxicity, and then move into Daphnia toxicity. Here are scanning electron microscope images of the tire wear particles we made in both micro and nano size ranges. Exposures of these particles were done individually at the various concentrations ranges listed under the images. These concentration ranges were dependent on the maximum concentration we could achieve during test material creation. Maximum concentrations were used in an effort to identify the level at which these particles become toxic. The micro and nanoplastics were loaded into 96 well plates from low to high concentrations as shown in the image. Micro and nano exposures were done individually and not in a mixture of sizes. To each well, a single zebrafish embryo at 8 hours post-fertilization was added. 4 plate replicates were done, which gave us an N of 32 for each concentration of each tire wear particle treatment, that is, micro, nano, or leachate. These were allowed to develop and assessed at 2 time points, at 24 hours and 120 hours post-fertilization. Mortality as well as a host of morphological and a couple behavioral abnormalities were assessed. The next few slides show significant abnormalities we observed during zebrafish development in the presence of these particles or chemicals in the case of the leachate. In this slide, as well as the next two, you will see the same style of heat map, so I will take a minute to familiarize you with the figure. On the x-axis, you see the concentration of the micro tire wear particle exposures. These are given in particles per milliliter. On the y-axis, you see the various endpoints that were assessed. In the green box, we have the things noted at 24 hours post-fertilization. In the yellow box, we have the morphological abnormalities noted at 120 hours post-fertilization. The unhighlighted line between the green and yellow boxes is for hatching delay. Normal hatching occurs around 72 hours post-fertilization. This y-axis will be the same for all heat maps I show. The x-axis values will change for the nanoparticles and leachate. Boxes in the figure that are red mean that at that concentration there was not a significant number of fish that had that malformation. And boxes that are blue mean that there were a significant number of fish that had that malformation. This was determined using Fisher's exact test with all concentrations compared to the control. The p-values were corrected using a Bonferroni correction for multiple comparison. Okay, now we'll talk about the slide itself. This heat map shows the results from the exposure of the embryonic zebrafish to the micro-sized tire wear particles. The first thing you'll notice is that none of the boxes associated with the yellow highlighted portion of the y-axis are blue. That is, at 120 hours post-fertilization time point, no significant malformations were documented in the zebrafish. Overall, we saw no significant mortality or hatch delay for the micro tire wear particle exposure. What we did find was a significant lack of spontaneous movement in embryonic zebrafish at 24 hours. Normally, a developing zebrafish is expected to show spontaneous movement at this time point, and these fish do not show this movement. We also noted a significant number of fish at the higher concentration which showed a delay in their developmental progression. Now we're looking at the heat map for the data for the nano tire wear particle exposure. The y-axis is identical to the previous heat map, and you'll notice the concentrations we used were much higher for this treatment at the size range than for the micro size range. At first glance, you will see more blue boxes in this figure than the previous one, even though it takes a higher concentration of the nano tire wear particles than the micro tire wear particles to first see a significant toxic response. However, on a mass basis, the micro exposures had a higher mass of tire particles than the nano. Similarly to the micro exposure, we see the lack of spontaneous movement at the higher concentrations of the nano tire particle exposure. In addition, we found a significant delay in hatching for larval fish beginning at the same concentration as the lack of spontaneous movement. We also found malformations of the axis and heart and the lack of touch response at the highest concentrations. Finally, this heat map shows the data for zebrafish exposed to increasing percentages of the tire wear particle leachate. The heat map is again set up in identical fashion to the previous two, except that the x-axis shows the concentration of leachate exposure in percent. As with the micro and nano tire wear particle exposures, we note a lack of spontaneous movement in fish exposed to leachate at 70% and above. Both the leachate and the nano exposure saw a disappearance of the touch response at increased concentrations, as well as pericardial edema. However, unlike the nano exposure, we did not see significant mortality or delay in hatching. Unique to the leachate exposure were significant abnormalities of the jaw, snout, eye, and yolk sac. These significant structural malformations begin around 80% leachate exposure and above. I will come back to recap these results in combination with toxicity to Daphnia at the end, but first let's discuss the exposures of neonate Daphnia to tire wear particles and leachate. So now I'll discuss the toxicity assessment we did for tire wear particles with Daphnia. Again, we see the scanning electron microscope images of the tire wear particles at the various concentration ranges listed under the images at which Daphnia exposure were done. As before, these concentration ranges were dependent on the maximum concentration we could achieve during test material creation. The micro and nanoplastic treatments were made up in 10 ml beakers as shown in the image. Micro and nano exposures were also done individually and not in a mixture of sizes. To each beaker, a single neonate of less than 24 hours old was added. 5 replicates were done for each concentration of each tire wear particle treatment, that is micro, nano, or leachate. These were assessed at 2 time points, 24 and 48 hours after the start of the exposure. At each of these times, the number of surviving neonates was recorded. For the data for the exposure of neonate Daphnia to tire wear particles and leachate, I will be showing several concentration response curves. As is typical, they have the concentration on the x-axis given in either particles per mil or percent for the micro and nanoparticles or leachate respectively. The figures also show the EC50 value, which is the LC50 value as well, because these curves are for mortality at the 48-hour time point, which was the last time point. Therefore, this is total mortality for the experiment. Here we see the micro tire wear particles and leachate exposure curves. Here the toxicity of the micro tire wear particles to the Daphnia appears to be attributed to the leachate released from the particles. This is due to the similarity in the curve. Moving on to the nano tire wear particle data, these curves are structured in the same format as the previous ones and show mortality at 48 hours. The first curve on the left shows the concentration of the nano tire wear particles that resulted in mortality of the Daphnia. The curve on the right shows the calculated leachate equivalency, that is the concentration of leachate that those amount of nano tire wear particles would be expected to release. From this we calculate the EC50 of 10.5%. of leachate corresponding to an EC50 of 3.4 times 10 to the 8 particles per mil of nano tire wear particles. The main point here, as with the micro tire wear particles, is that the toxicity of the particles to the Daphnia appears to be mainly explained by the leachate and not the particles themselves, though there may be some particle-enhanced toxicity. In summary, exposure to both micro and nano tire wear particles and leachate confers toxicity to developing zebrafish and Daphnia. Zebrafish exposure to each of the different treatments resulted in malformations unique to those particle sizes. The sole overlapping abnormality for all particle sizes and leachate was a lack of spontaneous movement at 24 hours before hatching. Additionally, the nano tire wear particle and leachate exposures both showed a lack of touch response and effects on the heart. So while these shared abnormalities may be attributed to the leachate, there appear to be particle-specific effects as well. The biggest takeaway from the combination of these two studies is that for different organisms, different components of the tire particles may be responsible for the toxicity. For example, for Daphnia, the mortality is primarily explained by the presence of the leachate. However, for zebrafish, the particle exposures showed different effects than the leachate exposures. Overall, the differing toxicity of the same tire particles to developing zebrafish and Daphnia highlight the importance of model organism selection and plastic toxicity assessment with a variety of organisms to capture the full range of effects of plastic pollutants. Thank you for listening to my talk, and thank you to everyone in the Harper Lab, Sarl for providing zebrafish, and to these funding sources. Check out the Pacific Northwest Consortium on Plastics to hear more about our work. Thank you very much.
And I will just add that we recently had that work published. I can post the link in the chat as well. And the Brander Lab had their work on mysids and silversides recently published as well.
Yeah, Brittany, we already put the links in there for
everyone. Perfect.
And I saw that you were keeping up with some of the questions as we were going through, but there is one that hasn't been addressed. So would you mind fielding this one? How did you count the particles in the microplastics and nanoplastics range?
Yeah, no problem. So unfortunately, there's not a machine that can do both of them at the same time. That would be really nice, but we have an Acuity flow cytometer that counts the micro-sized particles and then a nanosite, which can track and count nanoparticles. And it's not perfect, especially on the nanosite. It assumes that it is a sphere and these are fragments, but it is kind of the best current thing out there to count and track those particles that we make.
Okay, I don't see any other questions. Oh, Wayne, you have a question?
Go ahead, Wayne.
Yeah, Brittany, that was a great talk. So your dose response curves are really steep, aren't they? It's almost like a switch got turned off or on.
Yeah.
Yeah, can you hypothesize as to why that happens? To me, it looks like an OP where things are okay and they're dead.
It's a great question, and there is kind of a gap between the concentrations that we picked. This was a bit of range finding, especially at the start, and so these aren't many concentrations very close to each other, so there's quite a gap between some of the ones. I believe that one goes from somewhere around 300,000 particles per mil up to probably something like 600,000 or 700,000, and so it could be that our concentrations are just too far apart, and that if we focused on a very small level, we'd be able to narrow in on a less steep curve there. But I would say that's one reason for that. It also seems that it happens pretty quickly, that there is a switch between when this becomes toxic to them. And so we're actually doing chronic exposures right now. And so we're trying to zone in a little bit more too on what is toxic over chronic ranges as well. But I would say we're still kind of in the early days of looking at tire particles, but I'd say probably for the steepness of the curve, one of the reasons is just the range of concentrations we were looking at.
My other question would be, how does that compare to the measured concentrations that we've seen in other presentations and in the literature?
Yeah, it's a great question. The concentrations we were working at are pretty high. So at least by particle count there, I mean, we don't know particle counts for nanoparticles, but the micro ones are much higher than have been documented in the environment. We were kind of interested in looking at the point at which they become toxic, so we could pinpoint that. But based on a mass base, though, there are some early papers that identify masses similar to the masses of our micro exposures. So by count, we're pretty high, but mass-wise, we might be pretty similar to some of the things that are found out there.
Yeah, great result.
And that's, just to follow up, that's similar to what we did with the silversides and mysids, and that the counts were high, but if you look at the mass concentrations that have been found off both the west and the east coast, they tend to match those mass concentrations.
Yeah, and Suzanne, that's a great point, because in toxicology, we most always measure concentration by mass per volume. So that way it's more equivalent than how many particles, but and of course, chemicals are there too with the particles. So it's, well, Emma will talk about that later. No, great job.
Great job, Brittany.
And so I think with that, we will go ahead and transition. If you have other questions for Brittany, you can pop those in the chat as well. And I am going to take a turn here just to kind of refocus us on kind of where we started, and then we're going to launch into Wayne taking us to where we're going. So as you remember, this was Bremerton, the end of February 2020. This was meeting of the Pacific Northwest Consortium on Plastics, brought together 60 of us in live in person, and probably the last conference we've all been at for the last year. But we have nearly 250 stakeholders now that are a part of this group, and we're really focused on, sharing our research findings, trying to generate, consensus on science-based recommendations, and really trying to pool the data together to formulate, a functional multi-stressor risk assessment that decision makers could use. If you'll remember, if you were there in person, we a lot of the working day going through and kind of marking up these large boards and working through our prioritization of the stressors and the impacts that were important to our stakeholders. So we had several, at that time they were tables, now there'll be breakout rooms where we went through and did this exercise for various locations. At that meeting, Dr. Diana Lin presented on the San Francisco Estuary Institute's work efforts in compiling all of the data on microplastics in the Bay region and the Delta. And so this was a really rich data source to start with. And so this was kind of our initial data sets that we went to, and Wayne and Emma started using to flesh out the first ever microplastic specific multi-stressor risk assessment. And so I am not going to prolong this because I'd like for us to be able to spend some time in the breakout rooms. So I'm going to turn it over to Emma now, and she's going to share with you what she's done so far with just a portion of that data. And then we'll turn it over to Wayne to lead our breakout rooms.
Perfect. Thank you, Stacey. Okay, so my name is Emma, and I am working in Dr. Wayne Landis's lab at the Institute of Environmental Toxicology and Chemistry at Western Washington University. And today I will be talking about my microplastic risk assessment on the San Francisco Bay. So the goals for this case study were to complete an ecological risk assessment that can be used by our stakeholders in our study region, then to develop a framework that can be used by future microplastic risk assessments in other regions and other case studies, and then to show that a quantitative probabilistic risk assessment is possible with the microplastic data that is available. And really, we want to use this as an initial case study that we can learn from and can continue on to potentially other regions. So the method we're using for this case study is the Bayesian network relative risk model. And there's more information in Landis 2021 if you're curious, but a brief summary of the method is that we choose a study site. And because the study site is a pretty large region, we break that region up to smaller regions that we call risk regions. And this allows us to look at variations of risk across a large spatial region. In this case, you can see from the map that we broke up our study site into 4 risk regions. From there, we develop a conceptual model that places the stressor, in this case, microplastics, into context in the system. And then using that conceptual model as kind of a framework, we develop a Bayesian network model that actually uses the data that we have available to us and places it into a model that can calculate risk. And we'll go into more detail about this. But first, I want to talk about how we developed our conceptual model. So the framework we use to develop our conceptual model connects sources, stressors, habitat, effect, and endpoints. And I wanted to talk a little bit more about this because this is something we're going to be actually looking at together in our breakout groups in a little bit and developing these for different regions. So I wanted to talk about how we developed ours for this for this case study. So this is specifically for the San Francisco Bay. And hold on, okay. Got a little sneak peek. So first we outlined our sources. Now, some of these sources are going to be specific to the San Francisco Bay, and many of these sources will also be relatable to many other regions. I want to point that out. The other thing we did is we broke our stressor down into more specific sections. So in this case, we broke it down into microplastic, nanoplastics, and tire wear particles. We did this because there may be differences and significant differences in toxicity, fate, and transport. And we'll be able to flesh that out more as we have more data. Then we also wanted to include potential things that could affect toxicity, fate, and transport, like particle characteristics, sorbed contaminants, and water quality. The next thing we did was to determine our endpoints. So you can see on the far right-hand side of the screen, we have 5 endpoints, and these are specific to the region, our case study of San Francisco Bay. And this is something important as we're developing a risk assessment, is what do the decision makers, stakeholders, and regulators care about in this region? And from there, we look at the habitats that these organisms are in, where those cross over with the stressor, and then the effects that might be seen because of that. Okay, so from that conceptual model, we use that, like I said, as framework to develop our Bayesian networks. In this case, we've decided to do at least 2 different Bayesian networks, one for potential tire wear particles and one for other types of microplastics. We chose to do this again because of likely differences in sources, toxicity, fate, and transport. Today, we are just going to be talking about our Bayesian network for potential tire wear particles. So here's what it looks like, a example as we're kind of continuing to add on to this. Now this looks kind of overwhelming at first, so we're going to break it down a little bit. But the output from this ideally is the impacts to the endpoints and allowing us to calculate risk using various things and determining which variables might have the most impact on risk. So to look at this a little closer, you can see in the red box, we have our 4 risk regions that you saw in the map. And these allow us to, again, look at spatial variations in risk. So we can select each risk region and see how that changes the output. And then you can see in the blue box, or the second box, that we actually use the San Francisco Estuary Institute microplastic data set that Brittany mentioned and Stacey mentioned as well. This was a fantastic data set that allowed us to look at particles per milliliter in actual environmental samples for microplastics. They also looked at seasons effect on surface water particles, as well as wastewater treatment type on effluent. So we use that data there, and then we can connect it to our Oregon State University toxicity data. So Brittany just talked about 2 of these boxes. You'll notice that we have Daphnia mortality and zebrafish spontaneous movement. That is using the data that you just saw in those dose response curves. We take the equation from that dose response curve, we input it into our model, and it allows basically the model to take the concentrations from the environment that we input, and then to look at what kind of response level we see. From there, we summarize the toxicological effects, and then we can look at the output on actual fish abundance in the region. So we are using California Department of Fish and Wildlife data that looks at fish species abundance over a very large spatial and temporal range. And that can allow us to actually look at populations and how they vary over season and risk region as well. So that kind of allows us to look at the habitat as well as the exposure aspect of this. Okay. And the final piece is we are still working on this Bayesian network, and we're still going to continue to work on ones for other types of microplastics, but we do have some conclusions at the moment. And this is that with the data that is currently available, a quantitative spatially specific risk assessment is possible. Bayesian networks are an excellent modeling tool for the complex and uncertainty of microplastics. So Bayesian networks allow us to take data and kind of put it into context, but they also allow us to take new information as it's coming in and change that model so that it's more accurate and fits what we know. The other thing is that concentration response data and curves should be prioritized for microplastic toxicity testing. That is the data that we need to do a risk assessment, and we really encourage that work to continue to be done as toxicity testing continues. All right, please let me know if you have any questions or if you want me to clarify anything further. Thank you.
Thanks, Emma. Do Do we want to pass it to Wayne at this point? Oh, Scott has a question. Let's have a couple questions here and then we'll turn it over to Wayne. Scott? Oh, you're muted. Mute.
Oh no, I think you're. I totally understand.
Can you do sign language, Scott?
Oh no.
You must be having internet issues.
It looks like a very exciting question.
Still can't hear you, Scott. I'm sorry.
Okay, maybe write it in the chat, Scott, if you can.
Yeah.
Sorry about that. I know I've had that happen to me where I plug in my headphones and all of a sudden it messes everything up.
Absolutely. Always stressful.
Can you hear me now?
Yes.
Oh, sorry about that. Okay, I had to disconnect my headphones apparently. So great presentation, Emma. It's great to see the development of this work. I have a two-part question. The first is, how are you dealing with the non-alignment problem between the particle counts from, say, the Mantitrol data, which are going to be size biased in terms of the 33 microns, compared to the lab toxicity particle count data? And then my second question is, are you using the 1 liter grab samples to quantify risk in addition to the Mantitrol?
Yeah, great question. We are not using currently the grab samples. That data is available, but we're going to continue to talk to San Francisco Estuary Institute about that. And then for your first question, that is absolutely an uncertainty. The reality is that we will be able to be transparent about that. So, you know, just graphing and understanding exactly what that misalignment is, I think is really important. And until we have more data that matches more closely, we will just have to kind of work with what we have. But that's a really important uncertainty. So just to clarify for anybody, the lab data, toxicity data, is using slightly smaller particles than most of the data collected in the environment because of the collection methods that are just really available to environmental sampling. And I think that's something we're going to run into on and off for a while.
Great,
Scott,
thanks.
Yeah, Scott, that's actually a great point, how people go out and sample without understanding the toxicity and the range they may have, what the range of particles they may need to. And sometimes us as toxicologists go, well, here's the stuff we can get reproducibly in the laboratory. And sorry, it doesn't always match up with the field. And this also happens in regular chemical toxicology too, as all of us know. It's a huge uncertainty, but thank God for the data sets from Diana and everyone else.
Yeah, it's a great starting point.
Yeah, we put all these building blocks together and try to do calculation. Yeah.
Elise, go ahead. You had a question.
Yeah, thanks for the presentation, Emma. Super interesting. One question in terms of sort of data, I mean, you kind of just addressed this, but you know, if you're modeling risk for an area based on the San Francisco Bay data, field data, but if you're modeling risk for, say, Oregon or the Columbia River, it seems like the numbers may be really different. So it seems like we may be data limited. So I'm just wondering what if there are strategies, because it may not be the same concentrations.
Yeah, so that's a huge, really important piece, I think, of what we might talk about today, is that we need data for other areas in order to do risk assessments really without a huge amount of uncertainty in those areas. So, you know, theoretically, we could attempt to do some work using the San Francisco Estuary Institute data, you know, relating maybe land use and things like that. But the reality is it's going to be different. So yes, we need data specific to the area that we're doing a risk assessment, ideally.
So at least that was a setup question, wasn't it?
It was a good question.
No, the rest of it's gone. That was the setup. And we had not talked about that question at all, right? So yeah, it's not a setup. It's a huge issue.
Yeah.
Thanks.
Yeah, and as I had mentioned, a lot of the work we're doing in the San Francisco Bay can allow us to begin to learn a kind of be a framework for other regions as well. So it may be different data, but could be used as a framework, ideally.
So you want us to go ahead and go to part two, Stacey? Because I think between Elise's question and Emma's presentation, that's pretty much covers what the next part is.
I believe that Elise just kicked us to that next level.
Right.
Elise, so we didn't even plan that.
Yeah, and of course, Brittany's talk with all that nice dose response curve information and so forth. We're going to be talking about these things here. So I'm going to do my screen thing. One of the nice things about not teaching anymore is I don't seem to be spending so much of my life having to do this teaching. And you guys should be able to see something now. So we're building an ecological risk assessment and general way for microplastics and nanoplastics. And we have lots of questions. You've already seen the basic diagram that was in Emma's presentation. And we have a lot of scenarios. What I'm going to show you are 4 different scenarios. We're going to usually base this on what kind of questions that people have. And people really have simple questions about risk usually. Their questions are usually, and I always like to have maps, like where, what, when. Where are we talking about and when? Who has the expertise in a particular area? And who are the stakeholders? The stakeholders are really different. And we even heard that this morning with the representatives. It really depends on what state, what location, if it's federal, if it's local, land use people. I think zoning boards really manage most of the environments that I see. So who's going to be managing this? So it's one part of the scenarios. And then there are so many regulations, and we hinted to that California has its thing, Washington, so forth and so on. And what I usually see is that we're trying to manage these things with using a water quality management thing. Well, that's interesting. But most of the risk assessments my lab actually does is not microplastics, it's other things. So we're talking usually chemicals, sometimes invasive species, but a lot of times we're talking about water quality for both drinkability, swimmability, wildlife, pesticides, and so forth, and their impacts, marine systems, food. A lot of times I look at people counting these particles in food. I'm going, how do I do that? Of course, we have the classic laws like Superfund, Circula, TSCA, FIFRA, pesticides. And then what do we have that's actually microplastic specific? And there are relatively few microplastic specific frameworks. And the ones that are under development, I feel that we're running ahead of them right now, which is okay. But it's also, come on, guys, just hold it a second and let us get you up to date. So that's one reason we want to look at different scenarios. And the nice thing about the Northwest is we have the ability to do that. Emma showed this. This goes back now to the late 1990s. So I was only in my late 40s then. And it just has sources where things come from. The stressors are what are they? Where does it happen? The kinds of effects they produce, and the impacts are the things that we're interested in regulating. So this is a cause-effect pathway via Pearl and many other people. So we're assuming that it's cause and effect. This is also called a directed acyclic graph. And that's important when we come to do the calculations. And Emma just showed you the one that she uses to derive our Bayesian networks to do the calculation. And so we build it into a Bayesian network. And what we're going to be asking you to do is help us build this structure for 4 different scenarios now. We keep adding. And we have people located in the regions that we're going to talk about the scenarios in. So Emma showed you about the San Francisco Bay. We're also now, and this is Cindy Kuhn. That's her thesis, is the upper San Francisco estuary, also called the Delta, is large. It's in initial phases. We're going to present that a little bit. The Columbia River from Kennewick to Astoria, that's a long way, as those of us who are familiar with the region. But it basically takes us from a more agricultural area through the Portland Metroplex, and then out to Astoria in the Pacific. Puget Sound, Salish Sea. I just saw lots of sampling data from that area. And I'm basically thinking from the Budd Inlet up to Skagit Bay. And why Skagit? Well, we've actually done some work. actually, Carly Herring, who's on this talk too, she actually did work at one of the research estuaries in that area. So we're very familiar with it. And the last one, which is the smallest, but it's kind of neat, it's also very close to OSU, Akina River and the Bay, Elk City to Newport and the shoreline. So those are the scenarios we're going to talk about. We're going to ask people to break up into groups and actually talk. And we're going to like ask you questions and ask you to get feedback. Oops. Come on, you can do this. And we have these boxes. The sources are where the plastic's coming from and how much. That could be from the end of a pipe. Also, you can consider sediment as a source. The stressors, and we're mostly focusing on the microplastics and nano. I wish we had nano data. But what kinds of things are coming from that, and also what are the confounders? And those of us who've been involved with this know that pH, salinity, many other factors may actually change what form the microplastics, especially nanoplastics, may be to the biota. Also, are there other toxic constituents that can leach the materials? Of course, I'm thinking about tire wear particles. And there are also indications that when you go through dialysis with some of these particles, that the toxicity goes down. What are the landscapes that we're interested in? What are people actually managing? So that's the habitat location, both for what we're managing and also that the species that we are interested in occur. What happens next? The molecular to ecological. One of the things I liked about Brittany and Suzanne's and everyone's study, Stacey's study, is that it's more than just one effect. It's more than just mortality. Mortality ecologically in some ways is not very interesting because it's obvious. But the sublethal effects, things that cause a decrease in survivorship, are really important to populations. So that's where the molecular and the other kinds of materials are really important. And then we add all the probabilities together, or calculate them, and we get the impacts. And where do we use population models for particular species like some Monadas, which are always on the list, important forage fish, also things that impact water quality, which is what the PSANT program is very focused on. So those are the boxes. And we're going to ask you, these kinds of questions. Always keep in mind, where is this occurring? It's occurring upstream at the source. It's occurring in a sediment as it goes to the ocean. What are the things of interest as it goes through one of the metropolitan areas that we have, and we have lots of them in here. So I want you guys to be thinking about this as we go through it. Not only thinking about it, but where are the sources of data, both the tox data, the exposure data, and so on. Also, really try hard not to be normative in all this. This morning, I've heard people say, well, that's bad, or this is good. We do risk assessment based on specific criteria. Bad and good are hard to define. So here are the groups. And Stacey and guys, I'm going to ask you to break up our little meeting into 4 different groups. The first one's the Upper San Francisco Estuary. And Cindy's going to be involved with that. She's going to have lots of questions. Another reason we're using this one, we're actually doing a large-scale multi-stressor risk assessment on this region already, funded by the state of California. So we have the water quality data, all these kinds of materials already put together into a data set. The Columbia River, oh wow, because it's really a major pathway. Portland's on it. PSU is based there. There's other research going on. And again, it's a very important area. Puget Sound, Salish Sea, Bud Inlet to Sinclair, to Skagit. Again, a variety of habitats. We have some data. And then group 4, which is just down the road from Corvallis and up the road from Newport. It's a smaller area, but in some ways it may be easier to deal with. And at the end of all this, what we want to do, sit down, decide what our next study sites are going to be, and also start influencing, providing the feedback saying, if we just had this concentration in your study, we might have been able to do a better risk assessment. Or these are the sizes of particles and number of particles that seem to be important toxicologically. Can we target our measurement of exposure or field exposures to those kinds of criteria? And then we can come back and say what kinds of things we need to maximize those features. So that's what we're trying to do here. I'm just going to go through them. Some people may not know this. Sometimes we have people from other coasts. This is the San Francisco one, Sacramento, nice place. And then right off on this, to your left is where San Francisco Bay is. So we're doing that. And Cynthia, I've asked you to kind of keep track of that, and I'll pop in. Emma and Suzanne, Puget Sound, Sailor Sea. It's a neat place. And Elise, please feel free. Well, yeah, not Elise, but the people from UW Tacoma, please be you're more than welcome to provide some information and some feedback. Elise, you're coming up next. Oh, not quite next. Of course, we have lots of information about this, and then Columbia River and PSU and those kinds of studies. So I also have a daughter that lives in Portland. It's of interest to me, and it's a gorgeous place. But also, this is very typical of the West. It goes from pretty high desert, multiple stakeholders, a national forest, tribes, and of course, then you go out to Astoria and you can watch the Coast Guard train their PJs jumping into the water for rescues. Amazing environments. And Michaela and Elise, I just met you virtually. And Michaela's one of my students, and I'm asking you to fit into that. All right, so that's the deal here. And Stacey, if you can just set up the groups and we'll do the breakout. So Stacey, can we have another hour?
No, we even got to the point of putting down, identifying some names and people with potential data. So
yeah, we're gonna have to do more of that. But no, people were getting, and thanks to everyone managing the thing about defining a laboratory endpoint. It's not the same as a management endpoint ecologically. So there's a lot of different terminology, but it seems like I mixed up Puget Sound with the Columbia River. I'm going from group to group. It's like, okay, no, different things. So I just want to keep doing this. So send me an email if you guys are interested in still working with these groups. And now that we've seen some of you, we're going to start emailing people and doing it that way. The things I saw where people jumped right on it. There's a lot of interest in the sites. Frida asked a question that, Frida, you and I are of such an age, we even saw that stuff being reported about the resuspension of sediment after storm events. And I think I remember that from when I first got into CTAC. And you're muted, Frida.
I just remember a whole series of studies in which they essentially found that if you ignored storms, there was no sediment toxicity.
Yep.
There were high concentrations of, I don't know whether we're focused on heavy metals, but there were high concentrations in the sediment. And when you looked at what was resuspended during storms, then it accounted for the mortalities that they observed. Otherwise, oh, you can put as much pollutant in as you want. It just all disappears into the sediment.
I know, it's so frustrating.
Well, it must have been 10 or 20 papers that were focused on it, some major research projects that were focused on it. And I don't remember when.
I think we have a great Google Scholar working in our brains because we do remember that stuff. Just where to find it, that's where Google, find a citation, that's Google Scholar. The other thing is, feel free to contact any of the PIs associated with the consortium. Also, any of the people who are organizing it or each other. And I think, Stacey, I think it'll be cool to get these people involved in doing more risk assessments as part of our NSF grant.
Yeah, I took screenshots of the breakout rooms, so I know kind of where people aligned themselves. But I think we'll open it also up to the broader consortium for people that weren't able to make it today as well.
Absolutely. So I'm just going to be quiet because we're almost done, but I know you guys kind of want to summarize and stuff, but I really appreciate this, guys. And Emma, thanks for setting the stage, because Emma showed you guys what we can do with this, and along with all the students and all the research. So we can take the work you're doing and provide some feedback and actually make it in a format the decision makers use. So thank you all very much. All right, I'm done.
Yeah, and Wayne, I think one important thing that you didn't bring up, which I think people would appreciate, is that we can also use this, compilation to identify those data gaps where Oregon
Absolutely.
and Washington might want to invest money in collecting the data that we really need to flesh out these risk assessments. So.
Right, to ask the specific questions if you're going to be managing microplastics. I think I've had that talk with people before.
Yeah.
We'll just keep working on it.
I know.
Thanks,
I'll
everyone.
keep saying it too.
Thanks, everybody.
So Suzanne, I think we'll turn it over to you.
All right, sounds great. Well, thank you to everyone who has stuck around until the end. This was a great meeting this morning. Really enjoyed all the conversations and networking we got to do, and the great talks from Senator Das and Congresswoman Bonamici, as well as hearing from Julie Masura's group and Elise Granek's group as well. Lots of awesome work happening in the Pacific Northwest in both Oregon and Washington. We don't need the detailed schedule anymore. So just to close out, a few notes on upcoming meetings. Pacific Northwest CTAC is this week. It's actually starting, Stace, correct me if I'm wrong, it's tomorrow morning, right?
Correct.
Okay. Yeah, so I'll have another slide on that in a minute with more detailed information. CTAC Copenhagen. So far as we know, that's happening in person. That'll be in mid-May. And I've listed some of the sessions that are going to be happening that are focused on microplastics and nanoplastics. Stacey and I will have a session there with some colleagues from Europe. So we're super excited about actually getting to maybe leave Oregon for just a little while for a change. And then a couple to keep an eye out for are the International Marine Debris Conference, which I believe is going to be in South Korea in September. We're going to hopefully have a session. We've put in a session proposal for that one. And then CTAC Pittsburgh, Pennsylvania, is, as far as we know, happening in person in November, and sessions should be announced in a couple of weeks for that meeting, and then abstracts will be due by early June. So heads up on all of those, and if you want more information about CTAC events, you can go to that meetings and events page. Something to mention about Copenhagen is there is a virtual option too. So if you're not able to just pick up and go to Copenhagen, you can watch presentations online. For Pacific Northwest CTAC, the virtual meeting is again March 3rd through 4th, and there will be a live discussion panel on micro and nanoplastics. Tomorrow's Thursday. I've lost track of which day of the week it is. From 12:30 to 1:10, and it's not too late to register. You can still join. You can still register for that meeting even as late as today or tomorrow morning. And then, just an overall thank you to all of today's presenters, as well as to our leadership team and to the National Science Foundation for funding our group and all of this related research and networking. So thank you to everyone. It was great to see you all today. We are tentatively planning an in-person meeting for hopefully the end of the year, say our fall teleconference won't have the tele in front of it. It'll be a conference. So we can hope that will happen. It seems like things are moving in the right direction. So with that, unless anyone has any closing questions, we'll say goodbye for the day, and thank you again to everyone. Yes.
Suzanne, I just had one thing, and I just wanted people to know, if your group is doing something really cool and you would like to share it with the consortium, contact Suzanne or I, and we could potentially roll you into the next teleconference. I thought that worked really well today. So
really good point. And our next teleconference will likely be in the summer sometime. We'll probably have one in the summer, and then hopefully an in-person meeting later in the fall. Fingers crossed. Great. Thanks, everyone. Have a great rest of your week.